7 miles beneath the surface of the Western Pacific, where sunlight has not touched water for millions of years, a small instrument was listening. It was not large, it did not glow, it did not move with the confidence of a machine built for conquest. It had no window, no camera, no arm reaching into the dark. It was only a pressure case, a hydrophone, a recorder, a patient ear lowered through layer after layer of water until the ocean above it had become heavier than mountains. Around it was Challenger Deep, the deepest known place on Earth's seafloor, a trench so far below the waves that even the ordinary language of depth begins to feel inadequate. The water pressure there is not merely strong, it is absolute. It presses from every direction at once. It is the weight of the whole Pacific narrowed onto every surface, every seal, every bolt, every breathless space inside the metal. The instrument settled there in darkness, and then the strangest thing happened. It heard ships. Not ghosts, not monsters, not some hidden civilization moving through the black. Just ships. The low mechanical throb of propellers passed through the Hadal world from far above, a human pulse falling down through almost 11 kilometers of water. The sound did not belong there, and yet there it was. It had slipped through the sea the way distant thunder slips through the walls of a house at night, faint, changed, but still unmistakably made by us. The microphone heard earthquakes. It heard the deep acoustic signatures of the planet adjusting itself somewhere beyond the trench walls. It heard wails, not beside it, not near it, but carried from the open ocean in long, mournful shapes of pressure. It heard the surface, too. A storm that never came close to the seafloor still arrived as sound. A typhoon moved across the sky, above waves, above clouds, above the place where daylight ends, and the bottom of the ocean knew. This is the first contradiction. The deepest place is not silent. It should be, according to the imagination. It should be an absence, a final room, a sealed chamber beneath the world where nothing remains except cold, pressure, and time. But when scientists placed an ear in that place, the abyss answered with machinery, weather, animals, and the restless geology of the planet. The water did not erase sound, it preserved it, guided it, bent it, carried it farther than air ever could. In the human mind, the deep ocean is usually a visual mystery. We picture black water, pale fish, slow snow made of plankton and bone, the glow of animals that manufacture tiny moons inside themselves. But for the beings that live there, and for the machines we lower into that world, the ocean is often less a place seen than a place heard. Sight fails quickly underwater. Even in clear tropical seas, color begins to vanish almost immediately. Red goes first, then orange, then yellow. Depth takes the world apart by wavelength. By the time a person descends far enough, the bright surface has become blue, then gray, then nothing. But sound keeps going. It moves through seawater at roughly 1,500 meters per second, more than 4 times faster than it moves through air. It does not need sunlight. It does not care about the darkness. It passes through fog, night, distance, and pressure. It can bend around the curve of the Earth through the ocean's hidden layers. A low note can cross entire basins. A crack in Antarctic ice can be heard thousands of kilometers away. A whale can sing into the open water, and somewhere far beyond the horizon, another whale may receive that pressure as presence. So, if the deepest parts of the sea feel like mystery, it is not because they have no voice. It is because their voices are too low, too far, too slow, or too old for us to understand without instruments. The story of the deepest underwater sounds is not a list of strange noises. It is a story about listening to a planet that has been speaking beneath us the entire time. Long before a sound is given a name, it begins as motion. A plate shifts, a glacier cracks, a whale draws air into a body the size of a ship and releases a tone that seems less produced than opened. A volcano vents in darkness, a shrimp snaps its claw, and for a fraction of a second, a bubble collapses with violence so small and so intense that it flashes with heat. A storm kneads the surface into white confusion. A propeller turns. A sonar pulse leaves a hull. An iceberg drags its keel across a submerged ridge at the edge of Antarctica. Each of these events pushes against the water. That push becomes a pressure wave. The wave expands outward, not as a thing, but as a change moving through the sea. Water compresses, relaxes, compresses, relaxes. A hydrophone does not hear in the human way. It does not have a brain to decide what matters. It waits for pressure to touch it. It converts that changing pressure into electricity. It writes the disturbance into memory. Later, in a lab, a person looks at the recording as a spectrogram. Time along one axis, frequency along another, strength glowing in color. The ocean becomes a kind of handwriting. Lines rise, bands thicken, pulses repeat. Some signals are clean enough to feel designed. Others smear across the display like weather. Many are too low for human ears, so scientists speed them up, lifting them into our range, transforming geological time into something that can pass through a speaker. That is why some famous ocean sounds seem almost theatrical when people hear them online. They are not always presented as they truly moved through the water. They have been accelerated, compressed, raised, translated. The original sound may have unfolded over minutes. The original frequency may have trembled below the threshold of hearing. What reaches us is an adaptation, a version, a doorway. But even changed, the sounds carry something, a contour, a violence, a question. One of the most famous of all was recorded in the summer of 1997. It arrived on NOAA hydrophones as a broad, powerful sound from the southern Pacific, strong enough to be detected at great distances. Later, it would be called the bloop, a name so simple it almost made the event more unsettling. The word sounded harmless. The signal did not. When sped up, it seemed to rise quickly, a swelling organic note that did not resemble the ordinary machinery of ships or the short impulses of seismic events. It was loud. It was low. It appeared across sensors separated by enormous stretches of ocean. For years, it lived in the public imagination as one of the great underwater mysteries, the kind of sound that invites the human mind to populate the dark with impossible animals. It is easy to understand why. The ocean has always been generous to fear. It is large enough to hide anything the imagination needs. A sound comes from nowhere. A line appears on a spectrogram. The source is uncertain. The mind fills the gap with a body. But the deeper story of the bloop is not less fascinating because it likely came from ice. It is more fascinating. The best explanation points toward icequakes. Massive Antarctic icebergs cracking, fracturing, calving, grinding, and breaking under stress. These are not delicate sounds. Ice at that scale behaves almost like geology. An iceberg is not a floating cube. It is a wandering white continent, a mountain of fresh water with most of its body hidden underwater. When it fractures, it can release energy into the sea with a voice large enough to travel across ocean basins. A human standing beside a frozen lake might hear ice pop at night, a sharp report like distant gunfire. Now expand that to the size of a city. Expand it to the edge of a polar sea. Give it pressure, salt water, submerged ridges, tides pulling against frozen mass. The bloop becomes not a monster, but an event between worlds. Ice, ocean, gravity, and movement speaking at once. And the name remains strange. The bloop. A soft syllable attached to an enormous rupture. There is something almost human in that mismatch. We give small names to things too large to hold. We reduce the unfathomable to a handle so we can turn it in our minds. The ocean gives us a signal that crossed thousands of kilometers, and we call it a bloop. Other sounds followed their own paths through mystery. There was Julia, recorded in 1999 on an eastern equatorial Pacific hydrophone array. It lasted long enough to feel intentional in the edited version, a descending, haunted moan that seemed to come from somewhere near Antarctica. For years, it gathered a kind of folklore around it, not because scientists were careless, but because uncertainty has a shape. It invites stories to settle on it like snow. Julia, too, appears to have been ice, a large iceberg grounding on the seafloor somewhere off Antarctica, probably near the long, ragged margins where the Southern Ocean meets islands, shoals, and submerged ridges. Imagine the event without romance. A drifting mass of ice, moved by currents and wind, touches bottom. Its underwater keel catches. It does not stop instantly. It groans against the earth. It slows. It drags. Its motion becomes vibration. The seafloor becomes a bow. The iceberg becomes an instrument. The sound leaves the source and begins traveling. It does not travel as a scream. It travels as pressure, through a medium built for carrying pressure. Hydrophones thousands of kilometers away register the body of the event, not the image. No camera sees it. No person watches the keel bite into rock. The ocean keeps the scene hidden, but allows the sound to escape. That is the strange generosity of water. It hides and reveals at the same time. In the same family of sounds is the one called Slow Down, recorded in May of 1997. The name is almost a description, a signal descending in frequency over several minutes, as though some giant object were losing momentum. In this case, the likely source was again a large iceberg becoming grounded near the Antarctic peninsula. As it slowed against the seafloor, the sound dropped, stretched, sank. Heard through speakers after being sped up, it becomes eerie, almost intentional, as if something alive were exhaling across the abyss. But the poetry does not replace the physics. A moving iceberg contains immense kinetic patience. It does not need speed to be powerful. Its mass is enough. When that mass is interrupted by the seabed, energy must go somewhere. It becomes fractures. It becomes grinding. It becomes vibration transmitted into the water. The ocean receives the motion and carries it away. These recordings remind us that some of the deepest sounds ever captured are not from animals at all. They are from the cryosphere, from the frozen edges of the planet, breaking, grounding, resonating, and drifting. Ice is often imagined as silence made solid. In the ocean, ice is loud. It sings in narrow tones when it vibrates against the seafloor. It cracks in broadband bursts. It trembles under tide. It speaks in harmonics. It can sound like machinery, like thunder, like breath, like a train moving through a tunnel no one built. One recorded sound was literally nicknamed train, a steady, low-frequency signal around the low 30s of hertz, believed to come from an iceberg grounded in the Ross Sea near Cape Adair, its keel dragging slowly across the bottom. To human ears in the accelerated version, it has an industrial character, almost like wheels over rails. But there were no rails, no station, no human schedule. Only ice, bottom, and motion. The old polar world has its own engines. They do not burn fuel. They move by wind, tide, fracture, and melt. At the edge of Antarctica, the ocean is full of these slow collisions. Ice shelves calve, bergs rotate, deep keels scrape ridges. Frozen giants knock into each other in water so cold it seems outside ordinary life. Some signals travel into the Pacific, where hydrophone arrays designed for listening to other things receive them as distant testimony. And then, among the catalog of named sounds, there is upsweep. Upsweep is different. It was already present when NOAA's Pacific Marine Environmental Laboratory began recording the SOSUS system in 1991. It consists of long trains of narrow-band sounds, each sweeping upward in frequency over several seconds. It was powerful enough to be recorded across the Pacific. It showed seasonal patterns, often stronger in spring and fall. Its level declined over years but did not vanish. Its source remains unresolved. Scientists have roughly placed it in the southern Pacific, near a region associated with volcanic seismicity. That does not mean there is no explanation. It means the explanation has not fully closed. Upsweep sits in that important scientific space between ignorance and answer, where the unknown is not a license for fantasy, but a reason to listen better. The ocean still has sounds that do not introduce themselves. Upsweep is not as famous in popular imagination as the bloop, perhaps because it resists a clean story. The bloop had the dramatic arc of mystery and resolution. Upsweep is a recurring signal, an acoustic weather pattern of the deep earth. Maybe volcanic, maybe related to fluid movement, maybe some interaction in a remote and poorly observed place. It does not arrive as one spectacular event. It persists, seasonally, imperfectly understood. There is a special unease in repetition. A single unknown sound can be dismissed as anomaly. A repeating unknown sound begins to feel like a system. Something happens, then it happens again. It changes with seasons. It fades over decades. It belongs to a process, but the process remains hidden. If the bloop feels like a door slammed once in the dark, upsweep feels like a machine operating somewhere beyond the wall. And yet the ocean is not a haunted house. It is a physical world full of causes. The beauty of underwater acoustics is that it allows scientists to study places where eyes cannot stay. Hydrophones can remain where ships cannot. They can monitor volcanoes in darkness, earthquakes under remote ridges, whales across entire basins, icebergs on polar margins, human noise in sanctuaries, storms that leave no witness on the seafloor except pressure. Listening is not a lesser form of seeing. In the ocean, listening may be the primary way to know. The story of these recordings is also the story of a strange inheritance from war. During the Cold War, the United States Navy built SOSUS, the Sound Surveillance System, an immense network of seafloor hydrophone arrays placed across the Atlantic and Pacific to detect submarines. Its purpose was not wonder. It was vigilance. It was fear transformed into infrastructure. Cables ran from underwater listening posts to shore stations. Operators watched and listened for the low-frequency signatures of vessels moving through distant water. But the ocean did not only carry submarines. It carried everything. Whales crossed the arrays. Earthquakes rang through them. Volcanic eruptions announced themselves. Ice cracked. Storms roughened the surface. The system built to hear human enemies began to reveal a planet alive with acoustic events. After the Cold War, parts of that listening system became available for scientific use under controlled conditions. A military ear became, in part, an ecological and geological instrument. It was as if a wall of secrecy had opened slightly, and behind it was not only strategy, but whales. The reason SOSUS worked so well lies in a hidden feature of the sea, the SOFAR channel, or Sound Fixing and Ranging Channel. In much of the deep ocean, there is a layer where the speed of sound reaches a minimum, shaped by temperature and pressure. Sound waves entering this layer can be bent back toward it again and again, trapped in a kind of acoustic corridor. Low-frequency sound can travel enormous distances without losing itself quickly to the surface or the sea floor. It is one of the ocean's most extraordinary structures, and it is invisible. No diver sees the SOFAR channel as a tunnel. No submarine passes through an archway. It is made of gradients, not walls. Temperature decreases, pressure increases, sound speed changes, waves bend. The ocean quietly becomes a guide. A whale calling at the right depth can send its voice far beyond the visual world. A submarine can reveal itself. An underwater eruption can be located from signals arriving across an array. A cracking iceberg can become an event felt across half an ocean. The deep sea is often described as alien, but the SOFAR channel feels almost mythic, a natural highway for voices running through darkness, built not by hands, but by the physics of water under gravity. In air, distance softens sound quickly. A shout becomes a murmur becomes nothing. The atmosphere is restless and thin compared with the sea. It changes, scatters, absorbs. But underwater, especially at low frequencies, sound can become a traveler of almost impossible endurance. This is why the deepest underwater sounds are not always recorded near their sources. A hydrophone may capture an event from another world of water. The signal arrives with its original violence reduced, transformed by path, filtered by distance, but still legible. Scientists compare arrival times at different instruments. They examine frequency, duration, strength, direction. They turn ocean noise into geography. A sound becomes a map, and a map becomes a question. What happened there? Sometimes the answer is an earthquake. The ocean floor is not still. It is made of plates, boundaries, faults, ridges, trenches, fracture zones. At mid-ocean ridges, new crust forms. At subduction zones, one plate descends beneath another. Along transform faults, plates grind sideways past each other. The sea floor is a slow violence disguised as permanence. When earthquakes occur under or near the ocean, part of their energy can enter the water as sound. These signals, sometimes called T-phases, when seismic energy couples into the ocean and travels acoustically, can be detected by hydrophones over long distances. They are not like the cinematic crack of an earthquake in open air. They may arrive as low, complex bands shaped by the path from solid earth into water and through the sound channel. The planet rings through the sea. A hydrophone does not care whether a source is biological, geological, mechanical, or meteorological. It records pressure. The interpretation comes later. A whale moan, an airgun pulse, a ship, a quake, a volcanic tremor, an iceberg fracture, all become lines and textures. The first act of listening is humility. The ocean does not label itself. Underwater volcanoes add another register. Most volcanic activity on Earth happens beneath the ocean, along ridges and arcs that rarely enter public imagination. Submarine volcanoes can erupt into darkness, building seamounts, releasing gas, altering chemistry, creating habitats around hydrothermal systems where life gathers around heat instead of sunlight. When they erupt, they can produce acoustic signals, rumbles, tremors, explosions, harmonic tones, strange whistles. One NOAA sound called whistle was recorded in 1997 by a hydrophone in the eastern Pacific. It was an undulating, single-frequency signal, similar to sounds associated with submarine volcanic eruptions. Because it was detected on only one hydrophone, the source could not be confidently located. It might have traveled an immense distance from its volcano before being captured. The name whistle gives it a delicate feeling. But imagine a volcano under the sea. No plume rising into open sky, no red river of lava visible from a helicopter. Instead, molten rock meets cold water under pressure. Gas expands, rock fractures, new crust forms in darkness. The eruption may happen where no person is present, where no camera will arrive, where the only witness is an acoustic wave escaping into the ocean. The sea turns volcanic violence into tone. Underwater, the deep earth can sound almost musical because resonance is not a human invention. Pipes whistle, cavities ring, fluids oscillate, ice hums. A whale's body resonates, a submarine hull vibrates. The world is full of shapes that turn energy into frequency. The deepest sounds are not only deep because of where they occur, they are deep because they come from systems older and larger than the human ear. The ocean's low frequencies often sit near the edge of hearing or below it. A blue whale call may be felt more than heard if it could pass through a person at full scale. It is not a melody in the way birdsong is a melody. It is a long, low emission, a shaped presence in water, sometimes around 15 to 40 hertz, often beneath the lower limit of ordinary human hearing. These calls are among the lowest frequency and most intense animal sounds known. A blue whale is an animal so large that statistics fail to make it intimate. 30 meters, more than 100 tons, a heart the size of a small car, a tongue heavier than some elephants. But sound brings scale back into the body. The whale is not merely large, it is a moving chamber, capable of sending a low call into the ocean with enough power to cross distance that would erase almost any visual trace. To hear a blue whale through a hydrophone is to encounter a voice made for a world without walls. The calls are often sped up in recordings so people can hear them clearly. At normal frequency, they exist at the edge of us. They belong to water, not air. They were not made for human speakers. They were made for an ocean where visibility is poor, distance is immense, and another animal may be somewhere beyond the curve of the horizon. A whale does not need to see the receiver. It only needs the sea to carry pressure. There is something almost unbearable about that. A voice released into darkness with no guarantee of answer. A long note crossing shipping lanes, seismic surveys, storms, temperature layers, and the scattered noise of the modern ocean. Somewhere, perhaps, another whale hears it as identity, location, readiness, lineage, or something we do not know how to name. Blue whales are not the only low-frequency singers. Fin whales produce powerful pulses, often repeated in patterns, strong enough to dominate parts of the low-frequency ocean soundscape. In certain regions and seasons, the acoustic presence of baleen whales becomes one of the defining features of the sea. Their calls move through the same bands where ship noise also lives, the low frequencies from roughly tens to hundreds of hertz. This is not a small overlap, it is a collision of worlds. The large whales evolved voices for a quieter ocean, not silent, never silent, but quieter in the human bands. The 20th and 21st centuries brought engines, propellers, seismic air guns, sonar, offshore construction, and global shipping. Commercial vessels became a low, persistent weather in the sea. Their noise travels far, and lingers. It can raise the background against which animals must communicate. For a whale, silence is not emptiness. It is space. It is the acoustic distance available for a call to remain intact. When that space fills with machinery, the ocean changes even when it looks the same from above. A person standing on a beach may see a calm horizon and imagine peace. Under the surface, propeller noise may be passing through the water like traffic through fog. The sound does not always announce itself to land. It belongs to the submerged world. Hydrophones reveal it, and what they reveal is not always comfortable. At Challenger Deep, that was one of the surprises. Even the bottom of the deepest trench was not isolated from the surface world. Commercial and military ship traffic in the region contributed sound in low frequency bands. A storm passing overhead influenced the Hadal soundscape. The trench was quiet at times, yes, but not sealed. The deepest place on Earth still shared an acoustic atmosphere with the rest of the planet. That fact changes the imagination. The abyss is not elsewhere. It is connected. Every layer of the ocean is connected by pressure, chemistry, falling particles, migrating animals, and sound. What happens at the surface does not simply remain there. It descends, often transformed, sometimes weakened, sometimes carried with startling efficiency. A typhoon becomes a texture at the bottom. A ship becomes a pulse in Hadal darkness. A whale becomes a distant moan in a trench that animal may never enter. And then there are the clicks. If baleen whales make some of the lowest and most powerful sustained calls, sperm whales produce another kind of extreme. Sharp, intense echolocation clicks, among the most powerful biological sounds ever measured. These clicks are not songs in the blue whale sense. They are tools of perception, generated by a highly specialized head, focused and directional, used as the whale hunts in deep water. A sperm whale descends through the upper ocean and enters a world without daylight. It may dive hundreds or even more than 1,000 meters, searching for squid in cold darkness. Its body is large, but in the deep scattering layers and black mid-water, size does not solve vision. Sound does. The whale clicks. Each click moves outward, strikes bodies and boundaries, returns as echo. Through returning pressure, the whale builds a world. Not a visual image, but a sonic one. Distance, shape, motion, texture. The click is both a question and a measurement. What is ahead? How far? How large? Is it alive? Is it prey? To call this sound loud is technically true and emotionally insufficient. A sperm whale click can reach source levels around 230 underwater decibels in some measurements, though underwater decibels use a different reference pressure than air and cannot be compared casually to sounds in the atmosphere. Still, within the sea, the click is an extraordinary acoustic event. Brief, focused, intense. Not a voice thrown wide into the basin, but a beam of attention. The blue whale sends presence across distance. The sperm whale sends questions into darkness. Both are deep sounds, but in different senses. One is deep in pitch and reach. The other is deep in behavior, emerging from an animal that descends into the ocean's interior to hunt by sound. A sperm whale is not merely making noise, it is seeing with pressure. At the scale of small animals, the ocean grows louder still in unexpected ways. Snapping shrimp, only a few centimeters long, can fill shallow habitats with a crackling roar. They close a specialized claw so quickly that it creates a cavitation bubble. When the bubble collapses, it produces a sharp snap, a burst of sound, sometimes accompanied by a tiny flash of heat and light. Individual snaps can be remarkably intense for the animal's size, and colonies can create an acoustic field so dense that hydrophones record it as a continuous, sizzling layer. In warm coastal waters, reefs and estuaries can sound alive with shrimp. To a human swimmer, it may resemble frying oil, static, or distant rain on a metal roof. To instruments, it is an important part of the habitat's soundscape. The crackle can reveal biological activity, temperature changes, and the presence of healthy structure. Tiny claws become ecological instruments. There is a lesson hidden here. Deep sound does not always come from deep size. A small animal can make a violent acoustic event. A distant iceberg can sound alive. A whale can produce tones lower than the human ear. A storm can reach the abyss. A ship can enter the deepest trench without ever leaving the surface. Sound rearranges our sense of scale. It asks us not only what is large, but what travels. Not only what is visible, but what persists. The ocean is a library of events that never become images. A camera captures what passes before it. A hydrophone captures what passes through it. The difference is enormous. The hydrophone hears beyond sight, beyond weather, beyond darkness, beyond the immediate scene. It records a world made of arrivals. A sound can arrive from hundreds or thousands of kilometers away, and by the time it reaches the instrument, the source may have changed, moved, vanished, or died. The iceberg may no longer be grounded. The whale may be far away. The earthquake may be over. The storm may have dissolved into ordinary swell. But the sound has carried its signature through the water, and for a moment, the hydrophone becomes the point where distant history touches present pressure. This is why underwater recordings can feel haunted, even when fully explained. They are always late. They are the aftermath of motion. The ocean does not give us the event itself. It gives us what survived the journey. In 2015, when the hydrophone package was lowered into Challenger Deep, the operation required engineering that feels almost absurd in its patience. A system had to survive descent through nearly 11 kilometers of seawater, operate under crushing pressure, record continuously, and return. The instrument package included a hydrophone and pressure sensor. The recorder was protected inside a titanium case. It remained for weeks, collecting sound at the deepest known seafloor environment. To lower a listening device into that place is to perform an act of trust. Once it disappears beneath the surface, there is no easy intervention. It falls into blue, then black. It passes through temperature layers, through regions where animals migrate nightly, through mid-water vastness where marine snow drifts downward. It continues into the trench. The cable is gone. The ship is above. The instrument becomes independent. For days, it listens. No one hears what it hears in real time. There is only the hope that the batteries hold, the seals remain intact, the memory fills, the acoustic release functions, the package rises when called. Deep ocean science is often described through discoveries, but beneath each discovery is the quieter drama of retrieval. The ocean has taken many instruments and returned nothing. When the Challenger Deep Recorder came back, it carried weeks of sound from a place the human body cannot visit unaided. The expectation might have been near total quiet, perhaps interrupted by distant earthquakes. Instead, the recordings included a complicated soundscape: earthquakes, baleen whale calls, odontocete sounds, ship propellers, air guns, active sonar, and a typhoon. The deep was relatively quiet at times, but not acoustically sealed from the world above. This finding matters because it corrects a mistake in our emotional geography. Depth is not isolation. The trench is remote in distance, yes. It is remote in pressure, biology, and access. But acoustically, it remains part of Earth. It is touched by surface weather. It is crossed by human noise. It receives the voices of animals and the signals of geology. It is not a tomb. It is a room with walls so vast that echoes arrive from everywhere. Maybe this is why the recordings feel so strange. They do not make the deep smaller. They make the surface larger. The storm above is not just weather for sailors. It is sound for the abyss. The ship is not just a silhouette on the horizon. It is a pressure pattern at the bottom of the trench. The whale is not just a body moving through water. It is a voice moving through layers. All of it belongs to one ocean. There is a tendency in stories of underwater mystery to seek the singular sound, the loudest, the deepest, the strangest, the unexplained. But the truth is more diffuse and more powerful. The ocean is not defined by a few famous recordings. It is a continuous acoustic system where countless sources overlap, separate, mask, reveal, and transform one another. At any moment in the global sea, rain is stippling the surface somewhere. Wind is roughening waves. Ships are crossing lanes. Fish are chorusing in coastal darkness. Shrimp are snapping. Whales are calling. Ice is breaking. Sediment is sliding. Cables are humming. Volcanoes are trembling. Plates are shifting. Sonar is pulsing. Oil and gas exploration may be firing air guns in repeated bursts. Offshore construction may be driving sound into the water. A submarine may pass through the deep channel. A storm may become a low roar across hundreds of kilometers. The ocean is not a soundtrack. It is an environment. Animals live inside it the way land animals live inside light. Sound gives structure to their world. It allows orientation, hunting, mating, group cohesion, territory, warning, and migration. For some species, a change in sound is not background disturbance. It is habitat change. This is especially true because underwater sound does not behave like airborne sound in human rooms. It travels faster, farther, and with different losses. The frequencies that matter vary by source and environment. A high-frequency dolphin click may give fine detail, but does not travel across an ocean basin the way a low whale call can. A low-frequency ship engine may spread widely. A seismic airgun pulse can repeat with mechanical regularity. A reef's high crackle may dominate locally. The ocean is organized by frequency as much as by depth. Low frequencies can become long-range presences. Mid-frequencies can be active hunting and navigation signals. High frequencies can hold close detail. Each band is inhabited by different lives and different machines. When scientists speak of ambient noise, the term can sound bland. Ambient. Background. But in the ocean, the background is not empty. It is the total pressure climate of life and physics. It is what every animal must listen through. There is an intimacy in that. A whale's call does not travel through an abstract medium. It travels through the existing world, through shrimp crackle, distant shipping, rain, seismic pulses, and other whales. Communication is never pure. It is always negotiated with noise. The same is true of hydrophones. They do not receive a clean universe. They receive overlap. Part of the art of ocean acoustics is learning to separate the strands, to know the difference between a whale and a ship, between an iceberg and an earthquake, between a volcanic tremor and an instrument artifact, between mystery and misclassification. Some sounds are recognized by their shape. A blue whale call has structure. A fin whale pulse has repetition. A sperm whale click has sharp broadband character and directionality. Snapping shrimp crackle fills higher frequency bands in a distinctive way. Air guns repeat with industrial timing. Ships often produce tonal lines and broadband low-frequency noise. Earthquakes can arrive as complex energy with seismic relationships. Icequakes may show broadband bursts and harmonics. Volcanic signals can include tremor and tonal features. The ocean speaks in patterns. But patterns are not always answers. The famous unknown sounds remind us of this. The bloop was not solved by imagination. It was constrained by comparison. Similar spectrograms, known ice events, source directions, later observations of iceberg acoustics. Julia and Slow Down became less monstrous and more planetary as their likely sources were understood. Whistle remained limited by detection on too few instruments. Upsweep remained unresolved but bounded by plausible geophysical context. Science does not make the ocean less mysterious. It makes the mystery more specific. There is a difference between saying a sound is unknown and saying anything can be true. The first is careful. The second is surrender. Good listening requires patience with uncertainty, but also discipline. It asks what the sound could be, what it could not be, what paths it might have taken, what instruments heard it, what frequencies it occupied, what known phenomena resemble it. The ocean deserves that discipline. Its strangeness is already enough. No creature needs to be invented to make Challenger Deep astonishing. No hidden leviathan is required to make the bloop powerful. Ice cracking across thousands of kilometers is not a disappointment. It is a revelation of scale. A volcano whistling through water from an unknown source is not lesser than folklore. A blue whale sending a low call into the basin is not ordinary because it is biological. A sperm whale clicking into the dark is not less mysterious because it is understood as echolocation. The real ocean keeps exceeding the imaginary one. The imaginary ocean often depends on surprise. The real ocean depends on connection. One of the hardest things to grasp about underwater sound is that the ocean is not uniformly open. It is layered. Temperature, salinity, and pressure shape how sound bends. In warm surface water, sound speed can be higher. As temperature drops with depth, sound speed may decrease. Deeper still, pressure increases sound speed. Between these regimes, a minimum can form, and that minimum becomes the sound channel. A pressure wave is not a rigid arrow. It refracts. It curves towards slower sound speed, bending back into the channel. In the right conditions, it can travel without striking the surface or bottom, avoiding major losses. This is why low-frequency sounds can move so far. The ocean becomes a lens. For human beings, this is difficult to picture because we live in a world where sight dominates distance. We imagine straight lines, horizons, shadows. Sound underwater belongs to a geometry of bending. The shortest path may not be the path that matters. A signal may arrive in multiple ways, at multiple times, shaped by depth and profile. It may be weaker in one direction and stronger in another, because the ocean itself is not acoustically uniform. In this sense, the sea is not passive. It edits every sound. A whale call leaving a body is not the same as the call arriving hundreds of kilometers away. The ocean filters it, delays it, bends it, masks it, stretches its fate across many paths. A hydrophone records not just the source, but the journey. Each signal contains information about what made it and the water it crossed. That is one reason ocean acoustics can be used to study more than animals. Sound travel times can reveal temperature changes over basin scales because sound speed depends partly on temperature. Hydrophones can monitor undersea volcanoes and earthquakes in remote regions. Passive acoustic archives become records of changing human activity, seasonal biology, and climate-linked processes. The sea has memory, if one knows where to place the ears, but the memory is incomplete. A hydrophone listens from one point, an array listens from many. The more instruments, the better the triangulation, the better the confidence. A single hydrophone may hear something extraordinary and still leave its origin uncertain. 3 sensors can begin to locate. A network can transform mystery into coordinates. That is why the history of the deepest sounds is also a history of infrastructure. Cables, arrays, autonomous recorders, pressure housings, moorings, batteries, sampling rates, acoustic releases, archives, calibration, and patient analysis. Without instruments, the bloop is nothing to human beings. Without hydrophones, upsweep has no name. Without deep moorings, Challenger Deep remains imagined silence. Without long-term stations, changes in ambient noise remain anecdote. Every haunting ocean sound is also a triumph of engineering. A person may hear the edited recording and feel fear. Behind that moment is a technician sealing a pressure case, a ship crew deploying a mooring, a scientist checking gain levels, a data analyst scanning spectrograms, a funding program maintaining stations, a database preserving files. Wonder often arrives through logistics. There is something beautiful in that, too. Human beings built devices to listen for war, for whales, for earthquakes, for the changing sea. The devices listened beyond our intentions. They brought back not simply answers, but a new kind of humility. Because the ocean is louder than our old myths allowed. Not loud in the simple sense of constant roar. There are quiet places and quiet hours. Deep sound levels can be very low under calm conditions, but the ocean is acoustically alive. Its quiet is not absence, it is readiness. A calm sea at depth may hold faint, distant tones. A trench may seem still until an earthquake crosses it. A polar margin may rest until ice begins to move. A reef may crackle at dusk. A shipping lane may impose a continuous low band. A whale may pass once, leaving a call that becomes a line in data and a feeling in the chest of the person who hears it later. One of the most moving aspects of underwater recordings is that they often reveal life without image. A whale can be detected when no one sees its surface. A species can be present acoustically in darkness, fog, or distance. Long-term recorders can show seasonal migrations, daily rhythms, population-specific songs, and changes in behavior. In some places, scientists identify whales by call types and patterns, building a picture of movement from sound alone. This matters because whales spend most of their lives unseen. Even the largest animal on Earth disappears easily in the ocean. A blue whale surfaces, exhales, rolls, and sinks. The body is enormous, yet the sea absorbs it. From a ship, a person may catch only a blow, a back, a fluke, a line of disturbance, then nothing. But the call remains detectable. Sound restores continuity to lives that vision fragments. It lets scientists know an animal was there, or many animals, or a seasonal chorus. It can reveal when singing increases or decreases, when populations arrive earlier, when ship noise overlaps, when climate events alter feeding and calling. It does not replace visual study, it deepens it. For the animals themselves, sound may be even more fundamental. A whale's world is not the silent blue cathedral often imagined by people watching documentaries with orchestral music. It is filled with pressure information. The animal hears currents indirectly, perhaps through bodies, echoes, distant calls, surf, ice, rain, and the acoustic signatures of other lives. It lives in a medium where the far away can be intimate. To think about the deepest underwater sounds is therefore to think about perception. What does the ocean feel like to a being that hears farther than it sees? What is distance when a call can cross hundreds of kilometers? What is loneliness when a voice can travel beyond sight but still may not find an answer? What is noise when it does not merely annoy but reduces the space of possible contact? Human beings often treat sound as temporary. It happens, then disappears. Underwater, sound can become geography. It defines range. It opens or closes pathways. It is how the hidden world announces itself. The deepest recorded sounds also expose the limits of human hearing. Below about 20 Hz, ordinary hearing fades into infrasound. Some ocean sounds occupy this region naturally. They are not silent, they are simply below us. When scientists speed them up, they are not making them fake, they are making them accessible. They are moving the signal into the human window. This translation is necessary, but it changes the feeling. A sound that originally took minutes may become seconds. A frequency once felt as slow pressure becomes a moan, a sweep, a chirp, a roar. The listener encounters the shape of the event, but not its original duration. It is like watching time-lapse footage of a glacier. The motion becomes visible, but the experience of the glacier's own time is lost. The bloop, Julia, slow down, whistle, and many other recordings are often heard this way, sped up, filtered, compressed into human attention. There is no shame in that. Every instrument translates. A telescope translates distant light into images. A microscope translates scale. A seismograph translates ground motion into lines. A hydrophone translates pressure into voltage. Human knowledge depends on altered perception, but it is worth remembering that the true sounds belonged to another pace. The ocean did not hurry. The iceberg took its time grounding. The whale released its low call into a slow medium of distance. The volcano trembled in darkness. The earthquake traveled through rock and water. The storm rolled over the surface while the trench received it below. The accelerated recording is a keyhole. The real room is vast. Among all the famous sounds, the iceberg recordings carry a particular emotional weight because they connect acoustic mystery with climate and change. A cracking iceberg is natural, but the polar world is changing under human influence. Ice shelves thin, calving patterns shift, sea ice retreats in many regions. The acoustic life of polar oceans is not static. The sounds of ice are part of the planet's changing physical state. This does not mean every icequake is a simple symbol of climate change. The polar ocean has always cracked, groaned, calved, and moved. But long-term listening may help reveal changes in timing, intensity, habitat, and human activity in regions once buffered by ice. As polar waters open to more shipping or resource interest, the soundscape changes. A quieter world becomes accessible to engines. In the Arctic, for example, declining sea ice can alter both natural and human sound. Less ice may mean less certain kinds of ice noise at some times, more wave action at others, and more vessel traffic in places that were once difficult to cross. For animals adapted to acoustic environments under ice, these changes are not abstract. The ocean soundscape is climate made audible. Wind patterns, storms, sea ice, temperature, biological distributions, and human activity all leave acoustic traces. Listening stations become not merely microphones, but witnesses to transformation. The deepest sounds ever recorded underwater may one day include signals of a planet reorganizing itself. Some will be dramatic, ice breaking, storms intensifying, ships entering new routes. Others will be subtle, a shift in whale calling season, a change in ambient low-frequency levels, the disappearance of a once common chorus, the arrival of new biological noise in warming waters. The archive will not interpret itself, but it will hold the evidence. To stand beside an ocean and hear only waves is to receive the smallest surface version of its voice. Below that boundary is a far more complicated acoustic field. Rain sounds different from below, each drop striking the surface and injecting bubbles that ring. Wind creates wave noise. Breaking seas produce broadband energy. Bubbles oscillate, collapse, merge. The surface is not a line between sound and silence. It is a constantly played membrane. At depth, this surface weather can become a distant ceiling of noise. A hydrophone may record rain as a hiss, wind as a raised band, storms as broad energy. In Challenger Deep, even the passage of a typhoon was detectable. That fact is almost cinematic. A storm moving above, the deepest bottom listening below. The sky touching the trench through water. But no drama is needed. The physics is enough. Weather couples energy into the sea. Waves move, bubbles form, pressure fluctuations propagate. Layers carry some of that sound downward. The abyss receives a softened version of chaos above. There is comfort and unease in that connection. The bottom is not abandoned. It is also not protected. When humans add sound to the ocean, we enter a system already full but carefully evolved. Animals have found acoustic niches over immense time. They call at certain frequencies, durations, rhythms, depths, seasons. Fish choruses may occur at dusk. Whales may sing in migration or breeding contexts. Shrimp dominate warm reef crackle. The physical world has its own patterns of storm, ice, and quake. Industrial sound can cut across these patterns with different intensity and regularity. Ship noise often sits in low-frequency bands used by large whales. Seismic air guns can produce repeated, powerful pulses. Sonar can be intense in mid-frequency ranges. Construction noise can be loud and persistent. Even when a sound does not injure, it can mask. It can cause animals to change calling behavior, move, stop feeding, or experience stress. The word noise is human, but the consequences are ecological. A masking sound reduces the distance over which communication is possible. Imagine a fog lowering around voices. Not a visual fog, but an acoustic one. The animal may call louder, shift frequency, repeat, move away, or fail to receive. Each response has cost. Energy spent calling is energy not spent elsewhere. A missed signal can matter. In the deep ocean, where life is often sparse and distance immense, the acoustic reach of a signal can be vital. This is why monitoring matters. It is not enough to know that ships exist or whales call. Scientists need long-term records. They need baselines. They need to know how sound levels change by region, season, weather, traffic, and policy. Networks like NOAA's Ocean Noise Reference Station system are built for this kind of patient listening, collecting comparable data across regions to understand long-term trends. The work is not glamorous in the usual sense. It is repetitive, calibrated, archival. Instruments are deployed and recovered. Data are cleaned, measured, compared. But the result is profound. A way to hear the changing ocean not as anecdote, but as record. Every hydrophone becomes part of a larger question. How loud is the sea now? How loud was it before? What is natural variability? What have we added? What has disappeared? These questions become sharper when placed beside the famous, mysterious sounds. It is tempting to treat the bloop and its relatives as curiosities from the past, strange files in an online gallery. But they are also reminders of what long-range listening can do. A sound from a remote Antarctic iceberg was detected by instruments far away. A possible volcanic signal was caught across distance. An unresolved seasonal sound persisted for decades. The deep ocean leaves evidence in pressure, and if instruments are there, evidence can be kept. Without listening, the event may as well not have happened. Or rather, it happened without entering human knowledge. The ocean does not need witnesses, but we do if we want to understand the world we inhabit. The deepest underwater sounds are not necessarily the ones with the most frightening names. Some are ordinary to the animals that make them. Some are regular to the planet. Some are the routine consequence of ice meeting rock or water meeting wind. Their depth comes from context. A low whale call is deep because it belongs to a life lived on a scale we barely perceive. An iceberg grounding is deep because it turns frozen mass and seafloor friction into a basin-crossing voice. Challenger Deep recordings are deep because they prove that even Earth's lowest point participates in the planetary soundscape. The word deepest carries many meanings. Deepest in the water column, deepest in frequency, deepest in time, deepest in emotional effect. A sound from a whale may be biologically immediate, but it carries evolutionary time. A sound from an earthquake may last seconds, but it comes from tectonic processes millions of years in motion. A sound from ice may be a moment of fracture in a cycle involving snowfall, compaction, glacier flow, calving, currents, and melt. A sound from a ship may be recent, mechanical, and human, but it is now part of the ancient sea. The ocean accepts all sources without preference. It does not know natural from artificial. It carries pressure. The labels belong to us. In the archive, the signals sit side by side: whale, earthquake, airgun, ship, ice, volcano, unknown. Their coexistence is one of the most honest portraits of Earth. Life, geology, weather, and industry overlapping in the same medium. Not separate chapters, but simultaneous events. This simultaneity is hard to narrate because humans prefer clean order. We want a beginning, then mystery, then answer. The ocean offers entanglement. While an iceberg grounds near Antarctica, whales call elsewhere. Ships cross lanes, storms rise, shrimp crackle, and a hydrophone at depth records whatever reaches it. The soundscape is not a single story. It is many stories pressing through one another. And yet certain moments stand out. The bloop stands out because it sounded too alive before ice became the better explanation. Julia stands out because a grounded iceberg produced a signal with a human name and a mournful curve. Slow down stands out because its descending frequency seems almost narrative, the sound of motion becoming a rest. Upsweep stands out because it remains unresolved, recurring from a remote region, like a question asked in seasons. Whistle stands out because a likely volcanic signal reached one instrument and no more, leaving its birthplace uncertain. Challenger Deep stands out because the deepest place recorded, not isolation, but connection. Together, they form a kind of underwater mythology corrected by science. Not a mythology of monsters, but of processes. Ice becomes a singer. Volcanoes become whistles. Whales become long-distance presences. Shrimp become static. Storms become abyssal weather. Ships become ghosts in the trench. Earthquakes become oceanic bells. The world does not become less enchanted when the source is known. It becomes more densely enchanted. To understand that the bloop was likely ice is to imagine Antarctic mass fracturing with enough force to be heard over 5,000 kilometers. That is not mundane. That is almost beyond comprehension. To understand that a whale call sits at 15 to 40 hertz is to imagine an animal using frequencies at the edge of our hearing to maintain contact across enormous water. To understand that sound travels through seawater at about 1,500 meters per second is to realize that the ocean is not a mute barrier, but an acoustic engine. To understand that a storm at the surface can influence the soundscape of Challenger Deep is to feel the planet as continuous. Knowledge does not close the door, it opens a larger one. At the center of all this is a machine simple in concept, the hydrophone, an underwater microphone. But the simplicity is deceptive. A hydrophone must survive pressure, corrosion, biofouling, current, deployment error, battery limits, data limits, and time. It must be sensitive enough to detect faint pressure changes, but robust enough not to fail in a world that crushes weak designs. It may hang from a mooring, sit on the seafloor, drift, or connect by cable to shore. It may listen for days, months, years. It has no curiosity. That is its strength. It records the boring hours as faithfully as the extraordinary ones. It does not know when history is happening. It does not lean toward mystery or away from it. It gathers the low hum before the signal itself, and the return to hum. It preserves context. Human listeners arrive later with anticipation. The hydrophone has none. In some ways, this makes it the ideal witness for the deep ocean. The sea does not perform, it continues. The instrument waits. When a sound arrives, it is not framed by fear or wonder. It is only pressure. Then the human mind enters, and everything changes. A spectrogram of the bloop becomes a question. A whale call becomes a presence. A ship tone becomes evidence of intrusion. A volcanic whistle becomes a clue. A trench recording becomes proof that depth is not silence. The same data that begins as pressure becomes story, because humans cannot help but seek meaning in patterns. This is not a flaw. It is how science begins, as long as story remains accountable to evidence. The danger lies in loving mystery so much that answers feel like loss. Underwater acoustics teaches the opposite. The better the answer, the stranger the world becomes. Icebergs grounding on the seafloor are stranger than imaginary sea monsters because they are real and enormous and happening now. Sperm whales hunting with focused acoustic clicks are stranger than invented beasts because they truly descend into darkness and build a world from echoes. The SOFAR channel is stranger than a mythical tunnel because it is an invisible corridor made from pressure, temperature, and salinity. Challenger Deep being noisy is stranger than silence because it means no place on Earth is completely separate. The real is not smaller than the imagined. It is less obedient. The ocean refuses the shapes we expect. For centuries, the sea surface was the boundary of human certainty. Sailors knew storms, currents, reefs, whales, fish, wind, and depth by line. But the interior was mostly conjecture. Even after sonar and submersibles, the deep retained its distance. Cameras revealed startling creatures, but often in brief cones of light. Sampling brought bodies up dead or altered. The deep resisted continuous observation. Hydrophones changed that because sound is continuous where sight is fragmentary. A recorder can sit through the night. It can hear what passes beyond the camera beam. It can detect animals that never appear. It can remain during storms when ships leave. It can listen under ice. It can record remote eruptions. It can make the ocean's interior less episodic. This does not mean sound tells everything. It tells what produces pressure waves and what survives to the receiver. Many events are quiet. Many lives are subtle. Some signals are masked. Some are ambiguous. Sound gives access, not omniscience. But access is enough to transform understanding. In the early days of long-range underwater listening, scientists and military operators discovered that the sea carried low-frequency sound across distances that seemed almost impossible. Explosions could be detected far away. Submarines could be tracked. Whales could be monitored across basins. Undersea eruptions could be pinpointed. The ocean's hidden acoustic architecture became a tool. There is a moral complexity in this history. The same physics that allows whales to communicate allowed navies to surveil. The same hydrophone arrays that detected submarines later helped scientists study marine mammals and earthquakes. The same ocean channel carries whale songs and engine noise. Technology does not arrive innocent. It arrives with purpose, then exceeds that purpose. SOSUS was born from suspicion, but it also revealed the voices of whales. This is not redemption in a simple sense. It is history, layered like the ocean itself. Human fear built listening networks. Human curiosity repurposed them. Human industry added noise those networks could measure. The ocean became both battlefield and archive, habitat and signal path, wilderness and infrastructure. The deepest sounds recorded underwater carry this human contradiction inside them. We listen because we want to know. We also make much of what is heard. A ship passing above Challenger Deep is not mysterious, but its presence in the recording is profound. It means global trade, military movement, engines, fuel, propellers, and human roots are acoustically present in a place once imagined beyond us. We do not have to physically occupy the trench to affect its soundscape. Our pressure waves arrive before our bodies ever could. The ocean is not only deep space on Earth. It is a shared medium, and sound makes sharing unavoidable. One of the most delicate facts about underwater acoustics is that loudness underwater is difficult to translate for public imagination. Decibels in water use a different reference level than decibels in air, so a number like 188 or 230 underwater decibels should not be casually compared to a jet engine or gunshot in air. The physics of reference pressure, impedance, and measurement context matters. Without that caution, the numbers become misleading. But caution should not flatten awe. Within their own medium, these sounds can be extraordinarily powerful. A whale's low call can propagate for enormous distances. A sperm whale click can be among the strongest biological acoustic signals measured. Snapping shrimp, tiny as they are, can create intense local snaps. Air guns and sonar can produce powerful anthropogenic signals. Earthquakes and ice events can register across huge ranges. The better question is not whether an underwater decibel equals an airborne one. The better question is what the sound does in the sea. How far does it travel? What frequencies does it occupy? Who hears it? What does it mask? What behavior does it trigger? What process produced it? What path did it take? What does it reveal about the world? In that sense, the deepest sounds are not just powerful, they are consequential. A whale call may maintain contact. A click may guide a hunt. A shrimp snap may stun prey or defend territory. A ship may mask communication. A volcanic tremor may announce an eruption. An ice quake may reveal polar dynamics. A trench recording may overturn assumptions. An unresolved signal may direct future research. Sound is action at a distance. It touches before the source arrives. Sometimes the source never arrives. A whale call may pass a hydrophone from an animal that remains unseen. An iceberg sound may reach an array from a place no one is watching. A volcanic signal may be detected without eruption footage. A storm may be heard in a trench where no wave breaks. The sound is not a shadow. It is the event's pressure body, traveling independently. This independence gives ocean recordings their eerie quality. They are detached from images. A person hears Julia, but sees no iceberg, hears the bloop, but sees no fracture, hears upsweep, but sees no source, hears Challenger deep ship noise, but sees only darkness. The mind searches for a body to attach to the voice. When none appears, the sound expands. Modern science often tries to bring image and sound together. Tags on whales, arrays near volcanoes, satellite observations of icebergs, seismic networks, oceanographic measurements. Each layer narrows uncertainty, but there will always be sounds that arrive before their images, and some that never receive images at all. That is not failure. It is the nature of the ocean. There is another kind of deep sound that is less famous because it is not a single spectacular recording. It is the long, low presence of shipping. Global commerce has a voice, and that voice is mostly underwater. Cargo ships, tankers, container vessels, fishing fleets, naval ships, cruise ships, each contributes to the low-frequency soundscape. Propeller cavitation, engine vibration, hull movement, machinery, all transmitted into the sea. To humans above water, the ship is visible and then gone. To the ocean, the ship may be audible over vast ranges. This continuous human layer may be one of the most important underwater sounds ever recorded because of its scale. It is not named like bloop. It does not invite myths. It does not arrive as a single mystery. It is a condition, a background raised by movement. The difficulty with conditions is that they become normal. If you live beside a road, the traffic becomes part of thought. If whales live in an ocean of increasing low-frequency human noise, their acoustic world shifts around them. The old baseline may be lost before anyone measures it. This is why long-term sound records matter. They make the background visible, or rather audible, as data. They allow scientists to see changes that individual experience cannot hold. A reduction in shipping during a global disruption, a seasonal rise in whale calls, a storm trend, a shift in ice noise. All of these become meaningful when measured against time. For a documentary of the deepest sounds, the temptation is to dwell only on the spectacular. But the quiet accumulation of human noise is perhaps more unsettling because it is ordinary. No one ship is the whole story. All ships together become climate in sound. There are also sounds made deliberately to probe the ocean. Sonar pulses, acoustic releases, navigation pingers, scientific sources, seismic surveys. Some are brief and local, some are intense and repeated. Their purposes vary: mapping, communication, research, defense, resource exploration. They are tools, and like all tools, they reshape the field around them. A hydrophone may record active sonar as a clear signal in the water, a pulse that feels almost alien when heard through human speakers. It can be beautiful in a sterile way, like a question sent by a machine. But for animals sensitive to those frequencies, Such signals may be disruptive or worse, depending on context, level, distance, and species. Sound is not just information. It is force. At high enough levels, pressure waves can affect bodies. At lower levels, they can affect behavior. Even when they do neither visibly, they occupy acoustic space. The ocean is not an empty channel waiting for human use. It is already inhabited by listeners. This idea changes the ethics of listening. To listen is to recognize that others listen too. A hydrophone makes us aware of a shared sensory world. The sounds we produce do not vanish when we stop paying attention. They enter habitat. They travel into darkness. They cross paths with animals whose lives depend on acoustic cues far more than ours do. The deepest recordings are therefore not only scientific artifacts, they are reminders of responsibility. The deep ocean was once thought too vast for human influence. That belief has failed many times. Plastic in trenches, chemical traces, warming, acidification, fishing impacts, mining interest, and now sound. The Challenger deep recordings did not reveal catastrophic noise at every moment, but they did reveal connection. The deepest place is not beyond reach. The reach is acoustic. The reach is chemical. The reach is planetary. Still, the story should not become only guilt. There is wonder here that should remain intact. To hear a whale across distance is wonder. To detect an earthquake with a hydrophone is wonder. To learn that an iceberg grounding can sound like a descending moan is wonder. To know that the ocean has a natural sound channel is wonder. To lower an instrument into the deepest trench and bring back weeks of listening is wonder. To discover that the abyss contains not silence, but weather, ships, animals, and geology is wonder. Responsibility without wonder becomes duty without love. Wonder without responsibility becomes consumption. The ocean asks for both. In the public imagination, mysterious underwater sounds often drift toward horror. The black water, the low moan, the unknown source. It all feels designed for fear. But the longer one listens, the more the fear changes. It becomes reverence. Not because the ocean is safe, but because it is real. The unknown is not merely a threat, it is a measure of how much world exists beyond immediate human perception. The deep ocean does not need to frighten us to be meaningful. It only needs to continue being itself. A hydrophone recording from the abyss may sound eerie because it has no visual anchor, but the actual scene might be almost motionless. Fine sediment, sparse animals, absolute darkness, cold water, a small instrument waiting. The sound arriving there may have crossed immense distance. The drama is not in the frame, it is in the connection between places. That is a different kind of cinema. No monster emerges, no submarine lights reveal a ruin, no sudden answer resolves the mood. Instead, pressure moves through water. A storm above touches the bottom. A whale far away enters the trench as a line of sound. A ship passes in the low band. The seafloor waits. The ocean's deepest sounds are often cinematic precisely because they refuse spectacle. They unfold slowly. They imply more than they show. They come from beyond the edge of the frame. One could imagine the entire planet as an instrument being played by forces that rarely meet. Wind bowing the surface, ice scraping the margins, whales sounding the basins, shrimp crackling in reefs, plates striking deep chords along faults, volcanoes whistling through vents, engines adding drones, rain tapping the skin. the SOFAR channel carrying low notes through the hidden body of the sea. The instrument is not harmonious. It is complex, crowded, uneven, sometimes beautiful, sometimes damaged, but it is never mute. The deepest note may be from an earthquake spreading through ocean and crust. The deepest biological tone may be from a blue whale calling near the threshold of human hearing. The deepest recorded place may be Challenger Deep, receiving a surprising mix of natural and human sound. The deepest mystery may be Upsweep, persisting without a final answer. The deepest emotional sound may be whichever recording makes a person realize for the first time that the sea has been full of voices all along. There is no single winner. The title asks for the deepest sounds ever recorded underwater, but the ocean resists ranking because depth itself is layered. A sound can be low and shallow, loud and brief, distant and faint, biologically intense, geologically immense, emotionally bottomless. Perhaps the deepest underwater sound is not the lowest frequency or the loudest source level. Perhaps it is the sound that most fully reveals the hidden continuity of Earth. The hydrophone in Challenger Deep did that. So did the bloop, once understood as ice. So does a blue whale call traveling through a basin. So does the crack of a shrimp claw, proving that even small lives can dominate a habitat's acoustic texture. So does the long hum of shipping, reminding us that human civilization has entered the sea not only with hulls and nets, but with vibration. To listen to all of them together is to lose the old idea of the ocean as empty space. The ocean becomes inhabited pressure, a living, moving, breaking, singing, grinding, clicking, trembling body of water wrapped around the planet. And beneath every named recording is the same simple act. Something moved, and the water remembered for a while. That memory is fragile. A sound passes, it dissipates, it becomes heat, turbulence, nothing measurable. If no instrument is present, it leaves no archive. The greatest underwater sound in Earth's history may have gone unheard by human beings. A prehistoric landslide, an ancient volcanic collapse, a meteor impact in the sea, glacial cataclysms, earthquakes before instruments, whale choruses before ships, ice shelves breaking long before microphones, all gone as sound. We are late listeners. Hydrophones are recent ears placed into an ancient conversation. This should make the famous recordings feel even more precious. They are not the deepest sounds ever in an absolute sense. They are the deepest sounds we happened to catch, preserve, name, and study. They are fragments of an acoustic planet that existed before us and will continue after us. The archive is a window opened briefly in a storm. Through it, we hear enough to know we have missed almost everything. And still, what we have heard is vast. A large iceberg cracking near Antarctica can be detected across an ocean. A low whale call can travel beyond the horizon. A submarine volcano can leave a whistle in the data. A recurring, upswept tone can persist for decades without complete explanation. A deep trench can record the surface. A tiny shrimp can sound like static fire. A sperm whale can send a click into darkness and read the returning world. The sea is not one voice. It is a crowd of physical truths. There is a quiet human story in the act of naming these sounds. Bloop. Julia. Slow down. Upsweep. Whistle. Train. The names are almost childlike beside the events. They reveal something about us, our need to domesticate the unknown with language. A spectrogram becomes a character. A signal becomes memorable. A mystery becomes portable. But names can mislead, too. Julia sounds like a person, but it was likely ice. Slow down sounds like instruction, but it described motion. Whistle sounds small, but it may have been volcanic. The bloop sounds comic, but it traveled thousands of kilometers. Upsweep sounds technical, but it remains one of the more haunting, unresolved ocean signals. The name is only the surface. Below it is pressure, distance, and uncertainty. In that sense, the famous sounds are like buoys marking deeper water. They float in culture, easy to point at, but beneath them are the full depths of ocean physics, animal communication, climate, geology, and human noise. To stop at the name is to miss the descent. The descent matters. Start with the bloop as rumor, and it becomes a monster story. Follow it downward into ice acoustics, and it becomes a story about Antarctic mass, fracture mechanics, ocean basin propagation, hydrophone arrays, and the human appetite for mystery. Start with Challenger Deep as a silent void, and it becomes a fantasy of isolation. Follow the recordings, and it becomes a story about global connection. Start with Whale Song as beauty, and it becomes ecology, communication, masking, migration, and survival. The deeper one listens, the less simple anything becomes. This is the opposite of a lecture. It is what the ocean does to certainty. It dissolves hard edges. A sound is never just a sound. It is a source, a path, a medium, a receiver, and an interpretation. Change any one of those, and the story changes. A whale calling in quiet water is not the same as a whale calling near shipping lanes. An iceberg grounding near an array is not the same as one grounding without instruments. A volcanic signal on 3 hydrophones can be located. On one, it remains ambiguous. A deep trench with calm surface conditions is not the same as a trench under typhoon influence. Context is the ocean around the sound. Without context, mystery becomes decoration. With context, mystery becomes knowledge in progress. There are sounds still waiting in archives, not necessarily famous, not named, not circulating in online lists, but sitting in hours and years of acoustic data. Some are routine, some are artifacts, some may be rare events no one has examined closely yet. Long-term passive acoustic monitoring creates more data than humans can easily hear in real time. Algorithms help search, classify, detect patterns. But even algorithms require questions. The ocean is now being listened to at scales earlier scientists could not have imagined. Autonomous recorders can be deployed across remote regions. Cabled observatories stream data from the sea floor. Machine learning tools can identify whale calls, ship passages, and other signals across huge archives. Public databases preserve recordings. Researchers compare soundscapes across sanctuaries, parks, trenches, polar waters, and shipping routes. The deep is still difficult, but it is no longer acoustically unreachable. This creates a new relationship with mystery. In the past, an unknown sound might remain unknown because it was isolated. Today, more instruments, better models, and more comparative data can gradually narrow the field. But the ocean is large enough that uncertainty will remain. There will always be signals with incomplete arrays, complex propagation, overlapping sources, and remote origins. Mystery is not disappearing. It is becoming better recorded. The philosophical weight of the deepest underwater sounds lies here. They remind us that reality does not depend on human perception, yet human perception can be expanded. The iceberg was cracking whether or not we heard it. The whale was calling before we named the call. The trench was receiving storms before the recorder arrived. The SOFAR channel existed before navies and scientists used it. The ocean has always been acoustic. But until we listened, much of that world was absent from our awareness. Technology did not create the voices. It created the encounter. And encounters change the listener. Once a person hears the deep ocean as sound, the surface looks different. A calm blue horizon no longer suggests emptiness. A passing ship becomes an acoustic event. A storm becomes pressure descending. A whale surfacing briefly becomes only the visible tip of a much larger communication life. Icebergs become instruments. Trenches become receivers. The planet becomes less silent. This altered perception is one of the quiet gifts of science. It does not merely provide facts, it changes what the world feels like. A beach, after learning underwater acoustics, is no longer just sand and waves. It is the edge of a sound medium where pressure travels fast and far. A whale documentary, after hearing low-frequency calls, is no longer just imagery. It is an incomplete translation of a life organized by sound. A map of the Pacific, after learning about SOSUS and SOFAR, is no longer just geography. It is an acoustic field with hidden corridors. The world deepens, not by becoming darker, but by becoming more connected. The deepest sounds ever recorded underwater are often presented as isolated mysteries, but perhaps they are better understood as messages from connection itself. They show that the ocean links surface and abyss, pole and equator, animal and geology, war and science, climate and sound, human industry and remote habitat. A pressure wave does not respect our categories. It moves. In moving, it reveals the categories as fragile. The trench is not separate from the storm. The whale is not separate from the shipping lane. The iceberg is not separate from the equatorial hydrophone. The volcano is not separate from the listening array. The human world is not separate from the deep. This realization can feel heavy. It can also feel strangely tender. The ocean is not an outside. It is part of the same planet, the same body of conditions that makes life possible. Its sounds are not background to human history. They are part of Earth's history, continuing underneath the noise of cities, economies, weather reports, and ordinary days. Most people will never hear the ocean as hydrophones hear it. They will hear waves, gulls, wind, maybe the muffled thud of surf underwater near shore. The abyssal world will remain remote. But the recordings exist, and because they exist, the imagination has evidence to work with. Not fantasy alone, evidence. A titanium case at Challenger Deep, a hydrophone array in the Pacific, a spectrogram of ice, a whale call in low frequency, a volcanic whistle, a seasonal upsweep. These are not just curiosities, they are points of contact. Each says, the hidden world is active. Each says, listening changes scale. Each says, silence was never the right word. There is a final category of deep sound that is easy to overlook because it is not always named in dramatic catalogs. The sound of the seafloor itself becoming unstable. Submarine landslides, sediment flows, turbidity currents, collapsing slopes, and moving debris can create acoustic and seismic signatures that travel through water and ground. Some of these events are triggered by earthquakes. Some happen on continental margins where sediment accumulates until gravity begins to reorganize it. In deep time, such movements have shaped canyons, buried habitats, broken cables, and sometimes generated tsunamis. They are part of the ocean floor's slow housekeeping, though the word housekeeping feels too gentle for masses of sediment moving downslope in darkness. Imagine a continental slope after a long period of deposition. Rivers have carried material to the sea. Storms, currents, biological production, and gravity have placed layer upon layer onto underwater margins. The slope seems still because human time is short. Then, stress changes. Perhaps an earthquake shakes the pile. Perhaps gas alters stability. Perhaps the accumulated weight finally exceeds resistance. Sediment begins to move. At first, it may be local, a failure of structure. Then it gathers. It becomes a flow, dense and heavy, moving through submarine canyons like a dark avalanche. It may break cables. It may carry organic material downward. It may reshape the seafloor without a single human witness. If instruments are nearby, the event may leave sound, vibration, pressure changes, and a record of motion otherwise hidden. The deep ocean is full of such unseen rearrangements. They remind us that the seafloor is not a flat stage beneath the water. It is terrain. It has cliffs, trenches, slopes, plains, ridges, vents, canyons, scars, and unstable margins. Sound interacts with all of this terrain. A smooth abyssal plain reflects and absorbs differently from rugged volcanic crust. A canyon can guide sound. A trench can trap or shape it. A seamount can cast an acoustic shadow or scatter energy. The bottom is part of every underwater sound's journey. When people imagine underwater sound traveling, they may picture it moving through open blue emptiness. But the ocean is full of boundaries. The surface is a boundary. The seafloor is a boundary. Temperature layers are boundaries of speed. Currents and fronts alter conditions. Ice cover changes surface interaction. Even biology can form layers that scatter sound. Dense concentrations of fish or plankton, the deep scattering layers that rise at night and descend by day. An animal migration so large it becomes acoustic texture. The sea is transparent to sound only in comparison with air. It is not simple. Every signal is negotiated. A low-frequency whale call might travel far in the sound channel, but not infinitely. A high-frequency click may reveal detail but fade sooner. A ship's noise may be trapped, reflected, or damped depending on depth and conditions. A seismic event may couple into the water strongly in one region and weakly in another. A hydrophone may sit in a noisy local environment or a quiet one. The path is always part of the story. This makes underwater listening both powerful and difficult. It also makes it strangely personal to place. Two hydrophones separated by distance do not hear the same ocean. One may sit near a shipping route, another near a sanctuary, another in polar water under ice, another in tropical reef crackle, another in hadal darkness. Each receives a local version of the global sea. The ocean has no single sound. It has dialects of water. Some are biological, some are geological, some are human, some are seasonal, some are shaped by depth, some by ice, some by traffic, some by storms. A soundscape off a busy coast may be dense with engines, construction, fishing vessels, and biological calls squeezed into remaining spaces. A remote Southern Ocean recorder may hear more ice, wind, and whale signals, with ships appearing as occasional visitors. A coral reef recorder may hear intense high-frequency crackle and fish choruses. A deep trench recorder may hear distant earthquakes, surface weather, regional vessels, and the occasional animal voice. A hydrothermal vent field may include fluid flow, cracking rock, and the sounds of vehicles if researchers arrive. To speak of the ocean sound is like speaking of the land sound. A city, a forest, a desert, a glacier, and a cave do not sound alike. Neither do ocean places. This is why the deepest sounds should not be detached from their environments. The bloop belongs to polar ice and long-range Pacific listening. Julia belongs to iceberg grounding and Antarctic margins. Upsweep belongs to a remote region and unresolved geophysical suspicion. Whistle belongs to volcanic possibility and insufficient sensor geometry. Challenger Deep belongs to a Hadal Trench connected to surface and distant sources. Place gives the sound its body. Without place, it becomes pure mood. Mood matters, but place makes it true. The most careful ocean stories therefore move between the sensory and the specific. They let the sound feel vast, then locate it in the world. They allow darkness, then add coordinates. They allow fear, then bring in ice, whale, ship, storm, pressure, and path. The result is not the loss of atmosphere, it is atmosphere with weight. There is an old human habit of treating the unknown ocean as a screen for projection. We place dragons on blank maps, monsters in deep trenches, lost cities under waves, voices where ice is cracking. This habit is not only foolish, it is also an expression of hunger. Humans want the hidden world to answer emotionally. We want the dark to contain intention. But the ocean's actual answers are often more unsettling because they are not intentional. An iceberg does not try to sound mournful. A whale does not sing for human melancholy. A volcano does not whistle to be beautiful. A shrimp does not snap to become a metaphor. A ship does not mean to haunt the trench. These sounds move us because our minds encounter powerful processes without human purpose. That encounter can feel lonely. It can also feel liberating. The world is not waiting to be meaningful in human terms. It is already meaningful through relation, motion, and consequence. Sound exposes that. It lets us sense a universe of events that do not require us, but can still include us when we listen. Perhaps this is why the deepest underwater sounds feel philosophical. They are not philosophical because someone attached grand language to them. They are philosophical because they rearrange the listener's position. The human becomes small, but not irrelevant, limited, but capable of extension, late, but able to hear traces of ancient processes, responsible because some of the sounds are ours, humbled because many are not. The ocean does not explain itself in words. It gives pressure. We build meaning around that pressure. There is also an odd comfort in the fact that many of the most frightening sounding recordings have ordinary causes, if ordinary can mean icebergs the size of cities or volcanoes erupting in darkness. The explanation does not tame them. It places them in a knowable universe. It says the world is strange, but not arbitrary. It can be studied. It can be listened to with care. Care is different from control. No one controls the soundscape of the whole ocean, but humans can reduce some noise, protect some habitats, design quieter technologies, route ships more thoughtfully, regulate intense sources, and listen before acting. We can decide whether the ocean's future soundscape becomes more crowded by default or more carefully managed. The deepest sounds are therefore not just a look backward into recordings already made. They are also warnings about what future recordings may contain. Future hydrophones may hear more ships in the Arctic, more construction in offshore energy zones, more deep-sea mining activity if it expands, different whale distributions as prey shifts, changes in ice noise, more intense storm signatures in some regions, new mechanical sounds in places once known mostly by geology and life. They may also hear improvements where policy works, quieter vessels, protected quiet zones, recovering whale populations, restored habitats. The archive will judge choices with pressure. It will not moralize. It will record. That may be enough. A future scientist opening a long-term data set may hear what changed, and by then, the change will already be history. This is why listening now matters. The baseline cannot be reconstructed after it is lost. The ocean before a new shipping route, before a construction phase, before increased mining, before a climate threshold, before recovery or decline, must be heard while it still exists. Every present soundscape is temporary. The sea has always changed. But now, part of that change is accelerated by human action. The hydrophone becomes a witness not only to the ocean's mysteries, but to our decisions. And still, even in a changed ocean, there will be sounds beyond us. The Earth will keep shifting. Ice will keep breaking in some places and vanishing in others. Whales will call as long as whales remain. Shrimp will crackle where warm habitats support them. Storms will pass. Rain will drum. The SOFAR channel will bend low notes through darkness. Trenches will receive signals from above. Unknown patterns may emerge, fade, and return. The ocean's future will not be silent. The question is, what kind of noise will fill it? There is a quiet paradox in calling any of these recordings the deepest, because the word suggests a bottom, and the subject keeps opening beneath itself. A frequency has a bottom. A trench has a bottom. A data file has a beginning and an end. But listening does not. Each answer leads to another layer of water. The lowest note leads to the animal or force that made it. The source leads to the path. The path leads to the structure of the ocean. The structure leads to climate, geology, biology, and human history. What begins as a sound becomes a system. That is why the deepest recordings linger. They are not merely heard, they continue unfolding in the mind. After hearing an iceberg grounding, it becomes harder to look at polar ice as still. After hearing a blue whale, it becomes harder to think of distance as empty. After hearing snapping shrimp, it becomes harder to assume small lives are quiet. After hearing Challenger Deep, it becomes harder to believe any place on Earth is completely removed from the surface. After learning about Sosis, it becomes harder to separate knowledge from the histories that made certain knowledge possible. The sound remains short. The implications keep widening. There is also something strangely intimate about a hydrophone record. It contains no face, no eye contact, no gesture, none of the usual signals that create empathy. And yet, it can feel closer than an image because it enters the body through vibration. A low tone fills the room. A click startles the nerves. A crackle becomes texture. A descending sweep seems to move through the chest. Sound is physical in a way vision can forget. Underwater sound began as pressure in water. In the room, it becomes pressure in air. Then it becomes pressure in the listener. The deep arrives inside the body. This may be why people return to these recordings, even when they know the explanations. The explanation satisfies the mind, but the sound continues to operate below explanation. It is felt as scale, distance, darkness, and contact. It makes the hidden world momentarily present. That presence is fragile. A recording can be replayed, but the event itself is gone. The iceberg has moved or broken, The whale has traveled. The storm has dissipated. The ship has crossed into another sea. The earthquake has released its stress. The hydrophone may have been recovered, serviced, redeployed, or lost. What remains is the trace. A trace is not nothing. Much of science is built from traces: fossils, spectra, isotopes, waveforms, sediment layers, light from old stars, chemical signatures in ice, sounds from the deep. A trace is the past touching the present in a form that can still be read. The deepest underwater sounds are traces of motion. They tell us that something happened where we were not. They tell us the ocean carried it. They tell us an instrument was there to receive it. They tell us that absence, with the right tools, can become evidence. Even the gaps in the record have meaning. They remind us that the ocean is not fully archived, not fully translated, not fully turned toward us. There are still nights of ice no hydrophone caught, whale calls that passed through empty water, volcanic tremors that faded without a witness, and storms whose pressure never became data. The known sounds stand in a much larger darkness, and perhaps that is enough for awe. Not certainty over everything, not possession of the deep, only evidence that the unseen world is full of events and that listening can bring a few of them back. Somewhere in that question is the emotional center of the deepest recordings. They are beautiful not because they are pure, but because they reveal belonging. Even unwanted sounds belong to the record once made. A ship in Challenger Deep is part of the truth. An air gun pulse in a whale habitat is part of the truth. A blue whale call under shipping noise is part of the truth. The truth is not always the world as we wish it were. It is the world as pressure carried it. The work is to listen without turning away, to listen to wonder and also intrusion, to listen to mystery and also evidence, to listen to animals and also engines, to listen to the deep not as a fantasy realm, but as a real place receiving real consequences. When that is done, the deepest underwater sounds no longer feel like isolated curiosities. They become part of a wider act of attention, a way of noticing that the planet's hidden majority is not passive scenery beneath maps. It is an active, resonant, inhabited medium, crossed by forces and voices at every scale. The sea surface may glitter, but below it, the world is always being written in pressure. Sometimes the writing is a whale. Sometimes it is ice. Sometimes rock. Sometimes weather. Sometimes us. And sometimes the line rises on the spectrogram, and no one yet knows what hand made it. The more carefully one listens, the more the ocean's darkness begins to feel less like emptiness and more like distance. Things are there, events are happening, lives are moving through it, forces are shaping it, voices are crossing it. The lack of light is not lack of world. That may be the most important emotional correction. The deep sea is not a void. It is a place where the usual human senses fail. Sound enters where sight ends. At the bottom of Challenger Deep, there is no blue. There is no sunset. There is no weather in the visible sense. There is no horizon. But there is still a relationship with the sky because storms can be heard. There is still a relationship with human civilization because ships can be heard. There is still a relationship with life far above or far away because whales can be heard. There is still a relationship with the solid earth because earthquakes can be heard. The abyss is dark, but not disconnected. Imagine the hydrophone sitting there again, sediment around it, pressure around it, cold water moving slowly. No dramatic beam of light, no creature circling for the camera. Just an instrument waiting in blackness while the entire planet murmurs through the water. Far above, a ship crosses. The propeller turns, and each blade creates fluctuations, cavitation, mechanical rhythm. The sound enters the sea and spreads. It descends, bends, weakens, persists. Hours later, or moments later, depending on path and source, it becomes part of the trench's recording. Elsewhere, a whale calls. The call is low and long, shaped by a body adapted to the water's reach. It moves outward through layers. It may be intended for another whale, or part of a song, or a signal whose full meaning remains beyond us. The hydrophone receives it as distant energy. Somewhere else, the seafloor shifts. Rock breaks. Seismic waves travel. Some energy couples into the ocean. A signal crosses the deep sound channel and arrives as another line in the record. Above all of this, wind pushes the surface. A typhoon moves across the region, and the surface becomes white violence. Waves break, bubbles form. The sound enters the water column and reaches down, 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 until even the deepest place knows there is weather. The recorder writes it all without judgment. This is the ocean's honesty. It does not separate the beautiful from the industrial, the ancient from the modern, the living from the mechanical. It carries what is made. It allows every source to enter the same field. The archive may be uncomfortable because it is true. In that truth, the deepest sounds become a kind of portrait of Earth in the age of listening. Not pristine, not ruined beyond meaning, not silent, not fully known. Alive, noisy, changing, and connected. The bloop's likely iceberg source teaches that mystery can come from frozen mass breaking under ordinary planetary forces. Julia teaches that a grounded iceberg can sound like a lament. Slow Down teaches that friction and deceleration can become an eerie descending tone. Upsweep teaches that some persistent patterns still wait for full explanation. Whistle teaches that a single hydrophone can capture a volcanic clue, but not a complete answer. Blue whales teach that low-frequency voices can make distance social. Sperm whales teach that sound can be vision. Snapping shrimp teach that small bodies can dominate acoustic neighborhoods. Challenger Deep teaches that no depth guarantees silence. Together they teach that the ocean is best understood not as empty blue space, but as a vast, resonant body. To listen is to enter it differently. The earliest human relationships with the sea were shaped by surface sounds, waves on hulls, wind in rigging, surf on reefs, ice against ships, whales exhaling nearby, the slap of fish, the groan of wood. Sailors knew the ocean by what it did to bodies and boats. But the interior voice remained hidden. It took hydrophones, electronics, cables, and pressure-resistant instruments to hear below the surface at scale. Now, the old surface sea has gained an underworld of recorded sound. It is not always soothing. Some recordings are harsh. Air guns pound, sonar cuts, ships drone, earthquakes rumble, ice tears. Biological sounds can be raw and strange rather than melodious. The deep ocean does not compose for human relaxation. It does not provide ambience. It provides reality. That reality has texture. The low moan of a whale may feel mournful to us, but mourning is our projection. The descending sweep of an iceberg may sound like a creature, but the source is frozen mass. A sperm whale click may sound like a knock, but it is perception. Shrimp crackle may sound like static, but it is countless small actions of life. A ship may sound like distant thunder, but it is commerce. Listening requires both imagination and restraint. Imagination lets the sound become vivid. Restraint keeps the source from being replaced by fantasy. The best ocean stories hold both. They allow awe without abandoning accuracy. They allow emotion without pretending the whale sings for us, the iceberg mourns, or the trench waits. The ocean does not need human motives to be moving. Its indifference is part of its grandeur. A sound can feel sad without being sad. A sound can feel lonely without loneliness. A sound can feel ancient because it comes from processes older than language. The deepest underwater recordings often have this emotional ambiguity. They seem to speak, but not in words. They seem intentional, but often are not. They seem close, yet may be thousands of kilometers away. They seem present, but the event may have ended long before. That ambiguity is the source of their power. They exist between data and dream. In the laboratory, the spectrogram is measured. In the human chest, the sound becomes atmosphere. Both responses are real. The scientist may identify an iceberg. The listener may still feel the hair rise. The explanation and the feeling do not cancel each other. They occupy different layers. Perhaps that is why these recordings endure in culture. They let people feel the deep ocean without needing images. They are minimal and immense. A low sweep, a moan, a crackle, a pulse. Enough to open the black water in the mind. The danger is that culture often stops at the thrill. The deeper invitation is to ask what the sound reveals. Where was it recorded? At what frequency? By how many sensors? What source is likely? What does it say about propagation? What animals might hear similar bands? What human activities overlap? What environmental changes might alter such sounds? What remains unknown? Curiosity matures when it survives explanation. The ocean rewards mature curiosity because every answer contains another depth. Knowing that the bloop was likely ice leads to questions about how icequakes propagate, how polar events are detected, how climate affects ice acoustics, and how hydrophone arrays compare signals. Knowing that blue whale calls are low and powerful leads to questions about population differences, song frequency shifts, behavioral context, and noise masking. Knowing that Challenger Deep hears surface weather leads to questions about hadal connectivity, sound propagation into trenches, and human noise at depth. The answer is never the end. It is the next descent. In a world saturated with images, underwater sound asks for a slower kind of attention. There is often nothing to look at. The listener must remain with tone, duration, grain, and uncertainty. The imagination supplies darkness. The facts supply structure. The sound itself remains spare. This slowness is valuable. The deep ocean cannot be understood at the pace of spectacle. It operates in long intervals: tectonic drift, migration, seasonal ice, slow currents, whale lives, climate trends, sedimentation, evolutionary adaptation. Even its sudden events are embedded in long processes. An earthquake releases stress accumulated over time. An iceberg calves after years of glacial flow. A whale call belongs to a life history. A soundscape changes over decades of human activity. The recordings are brief doors into long systems. A 7-minute slowdown from an iceberg grounding contains years of snow compacted into ice, currents moving mass, bathymetry shaping contact, tides modulating motion, and hydrophones placed by human decisions. A few seconds of accelerated bloop contain a vast polar and acoustic context. A whale call contains lungs, anatomy, behavior, population culture, ocean conditions, and the ancient evolution of marine mammals from land-dwelling ancestors who returned to water. The sound is the tip of the depth. This is why an ultra-long telling fits the subject. The deepest sounds do not reveal themselves quickly. They need room. They need the slow unfolding of physical fact, emotional perception, and historical context. They need the listener to move from scene to system, from eerie noise to real source, from individual signal to planetary soundscape. The ocean itself teaches pacing. Nothing in the deep hurries for us. Even the sound that travels fast through water carries the feeling of distance. It may arrive quickly in physics, but slowly in meaning. Scientists can measure arrival times precisely, but understanding may take years. Public myth may grow first. Careful explanation follows. Some signals remain open, waiting for better tools, better data, or simply more listening. Upsweep remains one of those openings. It is tempting to give it a dramatic role because unresolved sounds invite drama, but perhaps its real significance is quieter. It shows that even after decades of acoustic monitoring, the ocean retains processes that are difficult to pin down. A recurring sound can be known in shape, but not fully in source. It can be mapped roughly, but not closed. It can decline over time, yet remain detectable. In a culture that often demands instant answers, upsweep is a lesson in unfinished knowledge. Not all mysteries are failures. Some are long observations. There is dignity in saying, "We hear it, we have clues, but we do not yet fully know." Science is sometimes most trustworthy in that sentence. The deepest sea is full of such sentences. We know some whale calls, but not all their meanings. We know ship noise affects marine life, but continue to measure the scope and context. We know ice makes powerful sounds, but changing polar conditions complicate the future. We know Challenger Deep is not acoustically isolated, but still have much to learn about Hadal soundscapes over seasons and years. We know hydrophones reveal remote events, but interpretation can be difficult. The unknown remains, but it is no longer blank. It has frequency. It has duration. It has direction, sometimes. It has a place in the data. That is a profound shift. The unknown becomes something one can return to, compare, monitor. It becomes part of an archive rather than a rumor, and archives change the future. A recording made today may answer a question not yet asked. A baseline collected now may reveal a change decades later. A mysterious signal may become clear when another instrument, another seismic record, or another biological study is brought beside it. The ocean's sound archive is not only a record of the past, it is a gift to future listening. There is tenderness in the thought that instruments are placed into the sea for listeners who may not yet exist. A hydrophone records a whale in 2015. A researcher in 2040 may compare it to a changed migration. A trench recording captures ship noise. Future scientists may ask whether the deep grew louder or quieter. Ice sounds archived now may become part of climate histories. Unknown signals may wait patiently until context arrives. The ocean stores no intention in these recordings. Humans do. We make archives because we know our senses are brief. We make instruments because our bodies cannot endure the deep. We listen because the world is larger than direct experience. The deepest underwater sounds are therefore also sounds of human limitation being gently extended. We cannot breathe there. We cannot hear those frequencies unaided. We cannot see across ocean basins. We cannot stand beside an iceberg keel dragging the seafloor under polar water. But we can build an ear, lower it, retrieve it, and listen later. This is one of the least violent forms of exploration: to listen rather than seize. Of course, listening alone does not guarantee care, but it begins with receptivity. A hydrophone does not illuminate, chase, drill, or capture. It waits. Passive acoustics, at its best, allows the ocean to reveal activity without demanding that every source be disturbed. There is something ethically important in that posture. The deep has been entered too often as resource, battlefield, dumping ground, frontier. Listening offers another relationship: attention. Attention is not enough, but it is necessary. When the deepest sounds enter human awareness, they complicate the idea that remote places do not matter. A sound from a trench, an iceberg, a whale, or a volcano can become emotionally present. It can make distance less abstract. It can turn the unseen into something felt. And what is felt may be protected differently. Not always. Human history is not so simple, but feeling can widen concern. A recording of a blue whale call does not communicate the full life of a whale, but it gives an encounter with presence. A Challenger deep soundscape does not show the trench, but it gives a sense of connection. The bloop does not show the iceberg, but it gives scale. Shrimp crackle does not show the reef, but it reveals hidden density of life. Each recording converts absence into relation. The ocean becomes less anonymous. The more individual sounds we recognize, the more the sea becomes a place of voices rather than a surface of blue. There is another way to think about these sounds, one that begins not with the instrument, but with the body. Human ears evolved in air. They are small chambers tuned for a thin atmosphere, for speech, footsteps, branches, animals in brush, weather approaching across land. Our hearing is intimate compared with the ocean's scale. Even when we hear thunder, we hear it through air, softened by distance and terrain. We are not built to sense pressure traveling through hundreds of kilometers of water. We are not built to feel a whale call as another whale might feel it. Not built to map a canyon by echo like a dolphin. Not built to notice the long tremor of a volcanic ridge in the low band. So, underwater sound requires a kind of translation not only between media, but between worlds of perception. A hydrophone does not simply extend the ear, it changes the kind of ear we have. It takes pressure fluctuations from a medium our bodies cannot properly inhabit, turns them into electrical signals, stores them, and eventually returns them to air through speakers or headphones. By then, the sound has crossed not only distance, but reality. It has moved from ocean pressure into data, from data into air vibration, from air into human nerves. The voice of the sea reaches us only after becoming something else. This is easy to forget when listening casually. A person clicks a recording labeled bloop or blue whale or Challenger deep and hears a file, a short burst of strangeness. But behind that file is a chain of transformations. The original signal moved through seawater. The hydrophone converted pressure into voltage. The recorder sampled it at a certain rate. Scientists may have filtered it. The signal may have been sped up so humans could hear its shape. Compression may have altered it further. A speaker then pushed air. The ear received the air, not the sea. What we hear is not false, but it is a translation of a translation. This matters because translation is never neutral. It changes scale. It changes duration. It changes emotional impact. A sound sped up 16 times becomes sharper, shorter, more dramatic. A low infrasonic pulse becomes audible tone. A long, slow grinding event becomes a haunting sweep. The human listener may feel a sudden thrill that the original sea did not contain in the same way. The ocean's version was slower, lower, perhaps less theatrical, but more immense. The true bloop was not a jump scare. It was a pressure event moving through an ocean basin. The true slow down was not a cinematic groan designed to unsettle us. It was likely an iceberg losing motion against the sea floor. The true blue whale call was not background music for awe. It was a biological act in water, directed into a world of other listeners. The true Challenger Deep soundscape was not a curated soundtrack. It was weeks of continuous pressure, much of it subtle, ordinary, repetitive, and only occasionally dramatic to human ears. There is humility in remembering the original scale. The ocean is not performing at our tempo. It is we who compress the ocean into our attention. And yet, compression can still reveal. Without it, many of the deepest sounds would remain inaccessible. Speeding up a signal is like translating a book from a language one cannot read. The rhythm changes, some texture is lost, but a door opens. The question is not whether translation alters the sound. The question is whether we remain aware that it does. Awareness keeps the mystery honest. It prevents us from mistaking the edited recording for the full event. It allows the sound to be both emotionally powerful and scientifically grounded. It lets us say, "This is what we can hear," and beyond it is the slower, lower, darker original. That original exists in a world where pressure is almost everything. At depth, the ocean is not just water, it is weight. Every 10 meters or so, another atmosphere of pressure is added. At 1,000 meters, the pressure is about 100 times what it is at the surface. At Challenger Deep, it is more than 1,000 atmospheres. The physical conditions are so severe that most human-made hollow objects fail unless carefully engineered. Yet sound passes. This is one of the paradoxes of the deep. Pressure destroys fragile structures, but it also provides the medium through which vibrations travel. The very water that crushes a weak container carries the signal of a storm, a whale, a ship, or an earthquake. The abyss is hostile to bodies, but generous to waves. A hydrophone must be protected from the first fact in order to receive the second. The instruments sent to the deepest places are therefore small acts of defiance against pressure. Titanium housings, ceramic sensors, glass spheres, acoustic releases, syntactic foam, battery packs, corrosion-resistant fittings. All of these are ways of asking an impossible environment to allow a brief conversation. The instrument descends with no drama visible from the surface. It becomes smaller and smaller beneath the ship. Then it disappears. During descent, it passes through the upper ocean, where sound is often busy. Waves, rain, nearby ships, marine mammals, fish, and biological crackles may fill the record. Then it passes deeper, through dim zones where sunlight fades and animals migrate vertically each night. Lanternfish, squid, gelatinous bodies, predators and prey move through layers that may be acoustically active in ways still being studied. Below that, the water grows colder and more stable. Human imagination grows quieter, but the instrument does not assume silence. It keeps listening. Depth does not erase the surface. It delays and transforms it. A storm overhead may sound different at 1,000 meters, different again near the sea floor. A ship's low-frequency noise may carry well through deep channels. A whale call may arrive by a path no eye could trace. The deep ocean is not a basement under the world. It is part of a vertical acoustic system. This verticality is crucial. Much of the popular imagination treats ocean sound horizontally. A whale calling across a basin, an iceberg heard thousands of kilometers away. But sound also moves between layers. The surface sends weather downward. Deep sources send energy upward and outward. Animals move vertically, carrying their own acoustic behaviors through changing sound speed profiles. A sperm whale clicking during descent is not in the same acoustic environment at 50 meters as at 800 meters. A hydrophone near the bottom receives a shaped mixture of signals filtered by depth. The ocean is not one room. It is a building without walls, made of gradients. Every floor bends sound differently. And some of the most important sounds are not the most dramatic ones. In many recordings, the deep sea contains low background hums, distant tonal lines, faint snaps, flow noise, instrument self-noise, and broad bands that shift slowly with conditions. These subtle sounds can be scientifically valuable. They reveal patterns. They define the baseline against which rare events stand out. They show how much acoustic space exists for animals. A loud mystery may attract attention, but a quiet baseline may reveal change. This is true in the same way that climate is not a single storm, but the pattern in which storms occur. A soundscape is not a single bloop, but the long-term character of a place. How often do ships pass? When do whales call? How loud is wind noise by season? Are there daily fish choruses? Does ice cover suppress or amplify certain bands? Are there new industrial sources? Does the low-frequency floor rise over decades? These are slow questions. They require listening that resists spectacle. A hydrophone can provide that if it stays long enough. Day after day, it records the ordinary. The ordinary becomes a reference. Then, when something changes, the change has meaning. A whale chorus begins earlier than usual. A shipping band grows louder. A storm season leaves a different acoustic mark. An eruption adds a tremor. A once common call becomes rare. The ocean's long story is written in patterns before it is written in famous events. Still, famous events have their place. They awaken attention. The bloop invited millions of people to wonder what could make such a sound. Julia and Slow Down turned iceberg physics into haunted audio. Upsweep kept a small door open to the unresolved. Challenger Deep recordings made the deepest place feel present. These sounds work like thresholds. People enter through strangeness, and if they keep going, they find science. The threshold is not the house. Beyond it is a world. In that world, every source has a physical signature. A ship's propeller does not simply make ship noise. The turning blades can produce tonal components related to rotation rate. Cavitation bubbles form and collapse, creating broadband noise. Machinery transmits vibration through the hull. Different vessel types, speeds, loads, and maintenance conditions shape the sound. A slow, large ship may fill low frequencies in one way, a smaller, faster vessel in another. In crowded lanes, individual signatures overlap into a low acoustic haze. To a hydrophone, human movement is not abstract. It has rhythm. The ocean hears our logistics. It hears trade routes, fishing effort, naval exercises, oil exploration, tourism, construction, scientific surveys, and sometimes silence when activity drops. During periods of reduced shipping, some monitoring programs observed changes in underwater noise. These changes were not simply quiet moments. They were experiments that no one could ethically stage at global scale, evidence of how much machinery contributes to the ocean's background. When human activity slows, the sea's acoustic floor can drop. Other voices emerge more clearly. This does not mean the ocean becomes pristine in a day. Natural sound remains, but the change can reveal how much of what we call normal is actually recent. Many large whales alive today inhabit a sea louder than the one their ancestors knew. Some populations recovering from whaling now return to acoustic environments transformed by ships. Their bodies carry old adaptations into a new sound world. There is tragedy in that, but also resilience. Whales still call. They shift, compensate, stop, resume, travel, gather, sing, click, and moan. Their acoustic lives are not erased by human noise, but they are changed by it. The task is to understand those changes before they become invisible. The same applies to fish, invertebrates, and habitats that receive far less public attention. Many fish produce sounds: drums, grunts, knocks, hums. Some form choruses at certain times of day or stages of reproduction. Larval animals may use reef sound as a cue for settlement. Invertebrate noise contributes to habitat identity. Sound is woven deeply into marine ecology beyond whales and dolphins. The ocean's famous voices are only the largest entries in a much broader choir. A coral reef can be acoustically rich. A healthy reef often crackles, pops, hums, and pulses with biological activity. A degraded reef may sound different. Restoration scientists have even explored the role of sound in attracting larvae or assessing ecosystem condition. The idea that habitat has an acoustic signature is still powerful. A place is not only what it looks like, but what it sounds like to those arriving in water. For a larval fish, a reef may be found not by sight from far away, but by sound. Home may begin as pressure. This widens the meaning of underwater recordings. A hydrophone can hear biodiversity indirectly. It can track human disturbance. It can reveal presence where visual surveys are limited. It can monitor remote protected areas without constant ships. It can help identify spawning aggregations, migration periods, predator activity, and habitat change. The deep ocean is less studied than coastal reefs, but the same principle holds. Sound is habitat information. In the hadal zones, where life exists under extreme pressure, the soundscape may influence animals in ways still poorly understood. Many hadal organisms may not rely on long-range sound as whales do, but they inhabit pressure fields shaped by geology, surface weather, and human noise. The biology of trenches remains incomplete. We know amphipods, snailfish, microbes, sea cucumbers, and other forms inhabit these depths. We know food falls from above. We know pressure reshapes physiology. But the sensory world of hadal animals is still far from fully known. What does ship noise mean to a creature living 10,000 meters down? Perhaps little, perhaps something. The honest answer requires study. That is why the Challenger Deep recordings matter beyond surprise. They establish that sound from surface and distant sources can be present at extreme depth. They invite better questions about how often, how strongly, through which frequencies, and with what biological relevance. They make the hadal soundscape real enough to investigate. A single record becomes a beginning. The history of deep-sea science is full of such beginnings. First images, first samples, first landers, first genomes, first sound records. Each one corrects a blank space. But the correction is never complete. It outlines a continent of ignorance. Sound is especially good at revealing that continent because it travels beyond observation. A hydrophone can hear something and prove that some process occurred even when no other sensor was there. It can also hear too much, creating ambiguity. A distant event may be detected, but not identified. A whale call may be present, but hard to classify. A signal may be distorted by propagation. The same strength that gives sound reach also complicates interpretation. Distance gives and takes. An event heard far away becomes known, but partly abstracted from its source. The path adds uncertainty. The signal is both evidence and riddle. This is why arrays matter. With multiple hydrophones, arrival time differences can locate sounds. With one, a signal may be fascinating but unresolved. Whistle is a good example. It had characteristics similar to volcanic signals, but because it was recorded by only one instrument, its source could not be precisely located. The ocean had given a clue, not a confession. A clue can be enough to keep listening. The same is true in biology. A rare call type may suggest a species or population. More recordings, visual confirmation, tagging, or regional context may be needed. Passive acoustics often works best when combined with other methods: ship surveys, satellite tags, environmental data, oceanographic models, seismic records, satellite imagery of ice, bathymetric maps. Sound opens a door, but other evidence furnishes the room. The deepest sounds, therefore, sit at the crossroads of disciplines. Oceanography, physics, biology, geology, engineering, climatology, signal processing, naval history, conservation, and even psychology all meet in them. A named underwater mystery may seem simple on the surface, but properly understood, it becomes interdisciplinary. That complexity is part of the atmosphere. The ocean does not divide itself by university department. A storm is meteorology at the surface and acoustics below. An iceberg is glaciology, oceanography, climate, and sound. A whale is biology, behavior, acoustics, conservation, and culture. A ship is engineering, economics, policy, and noise. A trench is geology, pressure physics, biology, and listening technology. A single hydrophone record may contain all of these at once. Long-form storytelling is one of the few forms that can honor such overlap. A brief explanation can identify the source. A slow narrative can let the source regain its world. Take Julia again. A short answer says, likely a grounded iceberg near Antarctica. That is useful. But the full scene is larger. Snow falls on a continent. It compacts into ice. The ice flows outward over years, centuries, longer. It breaks away into the ocean as a berg. Wind and current move it. Beneath the visible white, a keel extends deep into cold water. The berg drifts into a region of shoals or seafloor relief. It touches. The contact is not a clean stop, but a grinding negotiation between floating ice and solid earth. Tides pull, stress builds, fractures propagate. The ice vibrates. The water carries the vibration. Thousands of kilometers away, an instrument records it. Years later, a human hears it sped up and feels a ghost. That is not less mysterious than a sea monster. It is more complete. The same can be done for a blue whale call. A short answer says, low-frequency vocalization, often around 15 to 40 hertz, high source level, long-range communication. But the full scene begins with an animal descending or traveling through blue water. Lung capacity, muscular control, social context, seasonal movement, perhaps mating behavior, perhaps contact. The call is produced inside a body built by millions of years of return to the sea. It enters an ocean altered by temperature, bathymetry, background noise, and other animals. It may pass through shipping lanes. It may be heard by another whale, by a hydrophone, by no one. It may become a data point in a population study. It may become a sound file heard by a person in a city who has never seen a whale alive. The call links bodies that never meet. That is depth. Or take a sperm whale click. A short answer says, powerful echolocation click, possibly among the loudest biological sounds used for hunting. But the full scene follows the whale from the surface, where it breathes through a single blowhole, then arches and descends. The light fades. The pressure increases. The whale's physiology manages oxygen, nitrogen, buoyancy, blood flow. In darkness, it begins clicking. Each pulse is shaped by the animal's head and sent forward. Echoes return from squid, fish, other whales, perhaps the sea floor or layers of organisms. The whale interprets them faster and more richly than any human instrument can translate. It hunts by acoustic touch. The click is not merely loud, it is cognition in motion. Or take snapping shrimp. A short answer says, cavitation bubble collapse makes a loud snap. The full scene is a warm, shallow habitat where countless small animals occupy cracks, rubble, sponge channels, mangrove roots, reef structures. A claw closes. A jet of water forms. A bubble appears and collapses, releasing sound and force. One snap is tiny and sharp. A colony is a sizzling acoustic field. Fish, larvae, predators, and researchers all encounter that soundscape differently. It can interfere with sonar, indicate habitat, change with temperature, and remind us that scale in sound is not scale in body. The smallest orchestra can be deafening. The deepest sounds thus do something unusual. They make the physical world dramatic without requiring invention. They let ice act like an instrument, whales like long-distance stations, shrimp like sparks, volcanoes like flutes, trenches like receivers, storms like drummers, ships like intruders, and faults like bells. Yet none of these comparisons need to be literal. They are ways of approaching processes that are already expressive. The world is expressive because physics allows energy to take form. Humans hear that form and call it voice. But the ocean's voices are not equal in vulnerability. Ice will break without concern for our interpretation. Earthquakes will occur. Volcanoes will tremble. Storms will enter the sea. Human noise may change by policy and technology. Animal voices, however, belong to living populations that can be harmed, protected, depleted, or allowed to recover. This is why whale sounds carry a special emotional charge. They are not simply natural phenomena. They are signs of individuals and cultures. Some whale songs are learned and change over time. Populations have distinctive call types. The acoustic behavior of whales can reveal not only biology, but social transmission. When a whale population is reduced, the ocean loses voices, patterns, dialects, and acoustic traditions. Industrial whaling did not only remove bodies, it quieted parts of the sea. The recovery of whale populations, where it occurs, is also an acoustic recovery. More calls, more songs, more seasonal presence. Hydrophones can sometimes hear that return before casual observers see it. The comeback of voices is one of conservation's most moving forms of evidence. But recovery happens in a changed soundscape. The whales return to shipping noise, fishing gear, changing prey, warming waters, and new industrial plans. Their calls may travel through a sea that is no longer acoustically like the one their ancestors inhabited. The future of whale sound is not guaranteed by the survival of whales alone. It also depends on the acoustic space left for them. This is where engineering re-enters as hope. Quieter ship design, speed reductions, routing measures, protected areas, better regulation of intense sound sources, improved monitoring, seasonal restrictions, and awareness can reduce impacts. Sound is a form of pollution that can stop quickly when sources stop. Unlike plastic, it does not persist physically once the engine is gone or the pulse ends. The ocean can become quieter almost immediately in a given band if noise sources are reduced. That makes acoustic harm both serious and actionable. The sea can be given back some silence. Not absolute silence. The ocean was never silent. But space. Space for calls to travel. Space for animals to detect cues. Space for natural processes to define their own soundscapes. The word quiet in this context does not mean absence. It means balance. A quiet ocean can still contain whales, storms, shrimp, ice, rain, and earthquakes. It can be full of life and motion. It simply is not dominated everywhere by human machinery. That distinction matters because it avoids romantic fantasy. The goal is not to make the sea into a mute sanctuary. It is to let the sea sound like itself. The deepest recordings show us what itself can include. Itself includes violence. Ice cracking is violent. Earthquakes are violent. Sperm whale clicks are intense. Shrimp snaps are predatory. Storms are powerful. Nature is not gentle background. But natural soundscapes have histories of adaptation. Animals evolved with certain ranges of variability. Human sound often arrives suddenly in evolutionary terms, concentrated in frequencies and places where it can interfere. The problem is not loudness alone. It is novelty, persistence, overlap, intensity, and scale. A whale can live with storms. It evolved in a stormy ocean. A whale may not be equally adapted to constant low-frequency vessel noise in migration corridors. A reef can live with shrimp crackle. It may respond differently to construction pile driving. A deep trench can receive earthquakes. It may also receive human signals that did not exist a century ago. Understanding these distinctions requires listening carefully rather than speaking generally. The ocean is too varied for simple claims. A busy port, a polar soundscape, a remote abyssal plain, a coral reef, a submarine canyon, a hadal trench, and a deep-sea mining exploration area each have different acoustic characters. The same sound source can matter differently depending on local bathymetry, species, season, and background levels. This is why monitoring networks are regional and long-term. A single number cannot represent the sea. The deepest sounds are not just wonders. They are measurements from places, and places matter. Challenger Deep is not the entire deep ocean. It is a specific trench in the Western Pacific, with regional shipping, storms, geology, and acoustic pathways. The bloop's likely source region near Antarctic waters matters. Upsweep's rough location in the Southern Pacific matters. Blue whale calls vary by population and ocean basin. Snapping shrimp dominate certain warmer, structured habitats, not the empty abyss. Sound is always somewhere. Even a sound that travels far begins in a place. The more precisely that place is understood, the more the sound becomes part of Earth, rather than floating myth. Maps and spectrograms belong together. A spectrogram shows the shape of sound. A map shows the world that made and carried it. Alone, either can mislead. Together, they let the imagination descend accurately. Picture the Pacific not as a blue blank, but as a vast acoustic landscape. Trenches, ridges, islands, seamounts, shipping lanes, whale routes, volcanic arcs, sound channels, polar margins, equatorial arrays, deep moorings, surface storms. A sound leaves one part of this landscape and crosses invisible paths. It may be refracted, blocked by continents, scattered by rough seafloor, absorbed or guided. Instruments receive it or do not. The ocean is a sound geography, and geography changes fate. The slowdown signal, for instance, was strong enough to be heard by sensors thousands of kilometers away, despite complex paths and continental blockage influencing which sensors received it. That detail matters because it shows both the power of the source and the complexity of propagation. The sound was not simply loud everywhere. It traveled through a real planet with obstacles, channels, and geometry. Every underwater sound has such a fate. Some die near the source, some cross oceans, some remain below human hearing, some become famous, most vanish without witness. This vanishing is worth sitting with. It keeps the archive from feeling complete. The hydrophone record is remarkable, but it is sparse compared with the ocean's total acoustic history. Even now, there are vast regions and depths with limited monitoring. Many signals are never recorded. Many recordings are never fully analyzed. Many analyzed sounds never become public stories. The deepest sounds ever recorded are a small surviving subset of the deepest sounds ever made. That gap is not discouraging. It is humbling. It means the ocean remains larger than its catalog. The named sounds are not trophies taken from a conquered mystery. They are samples from an ongoing world. A long-form story should leave room for that ongoingness. It should not pretend that the final answer has been reached. It should move through what is known, honor what remains uncertain, and end with the ocean still sounding beyond the last sentence. Because that is what happens. After any recording stops, the sea continues. After the hydrophone is recovered, the trench continues to receive sound. After the bloop is explained, ice continues to fracture. After a whale call is classified, whales continue to call in ways we do not fully interpret. After a ship passes, another follows. After a storm fades, another forms. After an unresolved signal declines, another unknown may appear in some other archive. The deepest ocean is not a solved chapter. It is an active instrument under changing hands. There is an image that returns again and again. A spectrogram glowing on a screen in a quiet room. The room is ordinary. Fluorescent light, a desk, perhaps a coffee cup, cables, a researcher leaning in. Outside may be traffic, rain, evening. On the screen is a signal from thousands of meters down or thousands of kilometers away. A line rises, a band thickens, a pulse repeats. The researcher listens, speeds it up, checks the time, checks other sensors, compares known sources. The abyss enters the room as pattern. This is one of the great modern juxtapositions. The deepest sounds on Earth often become known in very undramatic places. Not on storm-lashed decks with lightning over black water, but in labs, offices, data centers, and archives. The drama is carried by the recording, not the setting. A person in a chair becomes the receiver of a polar iceberg, a whale, a trench, a volcano. The world folds inward. And then, sometimes, the sound leaves science and enters culture. It appears in documentaries, online galleries, discussions, art projects, music, horror stories, educational pages. It is remixed, misunderstood, exaggerated, corrected, rediscovered. The bloop becomes a meme of the abyss. Whale song becomes meditation audio or conservation symbol. Shrimp crackle becomes curiosity. Challenger Deep becomes proof that the bottom is noisy. This cultural afterlife is messy but meaningful. It shows that underwater sound touches something deep in human imagination, perhaps because it is disembodied, perhaps because it comes from darkness, perhaps because it suggests a world operating without us, perhaps because low frequencies affect the body before the intellect, perhaps because the ocean is the closest thing on Earth to an alien planet, and sound is one of the few ways it reaches into ordinary rooms. Whatever the reason, people listen, and in listening, they confront scale. The scale of distance, a sound traveling thousands of kilometers. The scale of depth, a microphone at nearly 11 kilometers. The scale of life, whales whose calls cross basins. The scale of geology, plates and volcanoes turning Earth into vibration. The scale of smallness, shrimp claws making explosive snaps. The scale of human influence, ships audible in the abyss. Scale is not only measured, it is felt. That feeling may be the deepest sound's true power. It turns numbers into atmosphere. 1,500 meters per second becomes not just sound speed, but the reason the sea is acoustically connected. 10,800 meters becomes not just depth, but the fact that a storm can reach the bottom. 15 hertz becomes not just frequency, but the edge of human hearing where a whale's life begins. 5,000 kilometers becomes not just distance, but proof that ice can speak across a basin. Facts become more, not less, when placed inside the felt world. This is the balance the subject asks for. Too much drama, and the ocean becomes a monster story. Too much explanation, and it becomes a diagram. But between them is something truer. The physical world allowed to be emotionally immense. The deepest sounds ever recorded underwater are not a single revelation. They are a series of openings. Each one leads downward into a different system. Together, they form a portrait of a planet whose hidden majority is acoustic, dynamic, and only partly known. The more we listen, the more complicated silence becomes. Silence in the ocean may mean no instrument nearby. It may mean frequencies outside human hearing. It may mean a quiet hour before a storm. It may mean a missing population. It may mean a masked signal. It may mean depth without surface influence for a moment. It may mean the listener lacks the right tool. True silence is rare. Perceived silence is common. The difference is the history of science. Once, the deep sea was thought barren because nets brought up little and pressure killed what rose. Then exploration revealed life. Once, the deep was imagined silent because human ears could not hear it. Then, hydrophones revealed sound. Again and again, the ocean's emptiness has turned out to be an artifact of inadequate access. The abyss was not empty. The listener was absent. Now, the listener is present in more places, and the abyss sounds different. It sounds like the planet. Still, the ending of this story should not resolve too neatly. The ocean continues beyond the recording. It does not pause for interpretation. Somewhere, at this moment, low-frequency sound is traveling through a sound channel. Somewhere, a whale is calling. Somewhere, an iceberg is grinding or cracking. Somewhere, a ship's propeller is turning. Somewhere, rain is striking the sea. Somewhere, an earthquake is preparing in silence before it becomes sound. Somewhere, shrimp are snapping in warm, dark water. Somewhere, a hydrophone is listening without knowing whether anything important will arrive. And beneath all of it, the deep remains dark. Not empty, dark. The difference matters. The darkness is not a lack of events. It is only a lack of light. Sound moves through it freely, carrying the signatures of bodies, weather, ice, rock, engines, and time. The ocean does not become known all at once. It arrives as pressure. It arrives as low tones and strange sweeps. It arrives through instruments brought back from places beyond the body. In the deepest recordings, the sea seems to speak from below the threshold of ordinary life. Not in words, not in messages, not for us. It speaks because everything that moves in water speaks somehow. A whale's call, a volcano's tremor, an iceberg's fracture, a storm's surface, a ship's engine, a shrimp's snap. The slow adjustment of the planet's crust. All of them enter the same medium. All of them become part of the vast, unfinished sound of Earth underwater. And at the bottom, where the pressure is enough to crush almost anything hollow, a small instrument listens. The water is black. The sea floor is still. Above it, the whole ocean keeps moving. A distant propeller fades into the low band. A whale note passes like a shadow made of pressure. Somewhere, far away, ice shifts against stone. The storm at the surface has already moved on, but a trace of it is still descending through layers. The recorder holds what it can. Then the sound thins. The trench returns to its colder murmur. Nothing is settled. Nothing is fully silent. Only the dark water, carrying what remains.